Hello, everyone, and welcome to the Google Automotive Partner Bootcamp in 2025. My name is Torsten Jung, and I lead automotive partner programs in Google's partner engineering organization. Before we start, just a reminder that everything we're sharing during the bootcamp, including this presentation, is confidential and bound by our mutual NDAs. Today, we have over 2,000 attendees from over 200 companies joining us in person and virtually from all over the world. Thank you for taking the time to be with us today. We really hope that you'll enjoy the immersive lineup of sessions during the next 3 days. For those of you who are here in person, please also join the numerous breakout sessions, office hours, and demos, including demos in the cars parked outside. Of course, we also hope that you'll use the opportunity to meet and connect with your colleagues from the industry who are all here with us today. Lastly, planning an event at this scale is no small feat. So a huge shout out to all the entire team and event organizers who made the bootcamp possible this year. Today, we are celebrating our 10th Google Automotive Partner Bootcamp. As I was preparing this keynote, I found this old slide from 2015, the same year that Google launched Android Auto and provided the world's first driverless ride on public roads with a team that would later become known as Waymo. It made me reflect on how far we've come as Google and as an industry. The second point on this slide states that only 23 million vehicles were connected in 2013. Today, that number is close to an amazing 450 million vehicles and still growing rapidly. For me, this is a truly exciting time to be part of the automotive industry. Throughout the years, the vision that drives us at Google has remained unchanged. We aim to create a safe and seamless connected experience in every car and be helpful in every drive. When people enter a car, they want to experience a surrounding that feels familiar, seamless and natural, and a connected experience that's adapted to the environment in the car to consume information, be entertained, stay connected with other people, and to interact with all the vehicle functions. These experiences continue to be increasingly defined by software and connectivity in cars. Google provides the technology, products, and services to enable the automotive industry to bring these experiences to consumer in a safe and secure manner. In 2006, Google offered the first product for the automotive industry, a proprietary Google Earth solution. We've greatly expanded our product offering since then. We've brought software and services to the industry at scale and have evolved and adapted our offering as the industry has transformed. Over the next 3 days, we'll be sharing updates across our entire product offering. Our partnerships with the automotive industry have been essential to fulfill our vision. Working with all of you, our partners, has helped us understand transformative trends in the industry, changing user requirements, and that motivates us every day to create solutions that meet the needs of our partners and users. We thank you all for your partnership and being on this journey together with us. To meet the varying product strategies of the industry, Google provides choice to automakers through a suite of solutions. As shown on this slide, these solutions can be categorized as follows. On the left, we have platforms with Android Automotive OS for infotainment systems, solutions for software-defined vehicles beyond infotainment systems, and smartphone integration with Android Auto, Cast for Cars, and Digital Car Key. In the middle, you can see apps and services from Google and third-party developers, optimized for cars, and available for our projected solution Android Auto and our embedded solution Cars with Google built in. On the right, You can see technologies from Google that enable the automotive industry to build their own highly customized and differentiated solutions. This category also includes tools in Google Cloud Services that simplify the development and testing of Android-based software to lower cost and decrease the time to market. Now, let me share a few updates about our platforms. Android Automotive OS is the Android variant for automotive infotainment system. It's an open source platform and has been adopted by a vast number of automakers. During the bootcamp, we'll be covering our plans for Android Automotive OS versions 14 to 17. There are 3 developments in Android Automotive OS that I'd like to highlight. The first one is display safety, Google's comprehensive solution for instrument cluster displays. The second one is scalable UI, our new approach to windowing that enables incredible user interfaces while at the same time simplifying compliance. And the third one is car-ready mobile apps, a set of compatibility features to expand the catalog of available apps. There's so much more that I couldn't put on this slide, but there are numerous deep dives over the next 3 days where you'll be learning a lot more about what's new in Android Automotive OS. As part of our platform offering, we also have a solution for software-defined vehicles, often abbreviated as SDV, going beyond infotainment systems and enabling a service-oriented architecture across the vehicles and to and from the cloud. SDV is a lightweight, handless version of Android that is performant, supports traditional IP-based automotive protocols, and with SDV version 1.0, we're launching the foundation of our platform that will enable the first SOP with a partner in 2026. We're also offering virtual development workflows for Android and SDV that run locally and in the cloud without any hardware dependencies. More on that in later slides. Please visit the demo area for demos of SDV and development workflows. And I've also been told they have a remote control car somewhere running SDV with backend telemetry and control. I haven't seen it myself, but I'll definitely be checking without, and I encourage you to do the same. We also have automotive platform solutions for smartphone integration. Let's start with Android Auto. Android Auto has been available since 2015 as a solution to project apps from Android phones to car screens. Since then, we've added many features and made numerous quality improvements. 250 million cars globally now support Android Auto, and 98% of new cars are equipped with Android Auto. It's really been a tremendous success story. Cast for Cars brings entertainment from over 5,000 apps on phones directly to car screens, including live TV, movies, and music. With Cast for Cars, there's no need to install or sign into an app on the car side, and it works with iPhones and Android phones. The first automaker launched Cast for Cars earlier this year, and more automakers will follow. Digital Car Key eliminates the need for physical car keys. Users can lock, unlock, and start the car with their phone or watch, and securely share keys with their family and friends that have Android or iOS devices. We continue to standardize this offering, working closely with the Connected Car Consortium. Digital Car Key is now available on many Android phones, and more than 10 different car brands and a growing number of automakers have decided to adopt this technology. We're also actively working to make the integration and launch of Digital Car Key easier for our partners by investing in certification and test automation. That brings us to our second pillar, apps and services, which are highlighted in the middle of this slide in yellow. Gemini, the AI assistant from Google, was launched on phones early last year and will soon be available in cars. Hands-free voice commands with Google Assistants have always been at the core of Android Auto and cars with Google built in. Gemini will upgrade that experience by understanding what users want while driving through natural conversations. So instead of focusing on the perfect prompt, or tapping the right button, users can stay focused on the road ahead. Users can not only find the best route, but also get help along the way. For example, if a user wants to relax and take a walk while the car is charging, Gemini can help to find a charging station with a park nearby. By connecting to messaging apps, Gemini can summarize messages and help to craft a reply and even translate it to another language before sending. Gemini also connects to Google Maps and other apps, from YouTube Music to Spotify to Google Calendar, to find exactly what a user needs to take action. Gemini Live is a conversational experience that can be a helpful driving companion. Just say, "Let's talk," to Gemini to enter a conversational mode to brainstorm ideas or learn something new. For example, I was recently on a very long drive and used Gemini Live to help me prepare this keynote and exchange some ideas. Gemini will be available in cars that support Android Auto in the coming months and in cars with Google built in later this year. We recently demoed Gemini in cars at Google I/O, and over the next 3 days, you can also experience Gemini yourself in demo cars that we have parked outside. For cars with infotainment systems that are based on Android Automotive OS, we offer 3 Google services that have been adopted for automotive use cases and that can easily be integrated in AAOS-based infotainment systems. We refer to cars with these services as cars with Google built in. Some of you may also know these as Google Automotive Services, or GAS. The 3 services include Gemini, Google Maps, and the Google Play Store. Over 50 car models worldwide have already been launched with Google built in, and today, many users are enjoying these in their daily drives. The cars on the road today still use the old Google Assistant, but towards the end of this year, the first automakers will replace the Google Assistant with Gemini, and we expect that other automakers will follow. We are continuously improving all 3 services and are bringing improved and new features to cars nearly every month with automatic updates via the Play Store. No action needed by the automaker. For example, Google Maps will soon offer improved filtering for EV charging stations and new UI customization options. And the Google Play Store will have an improved UI and easier cross-device discovery for car-optimized apps. Speaking of the Play Store, we are bringing more app categories to the Play Store, and the number of apps that are available for download in cars with Google built in is rapidly increasing. Over 300 apps are already available today, and we expect over 600 apps will be available at the end of this year, and over 1,300 apps at the end of next year. We'll continue to focus on app categories and apps that users want in cars. The game of chess, for example, has proven to be a big hit with users. On the other hand, I'm assuming no one will want to file their tax return from their car, so that's probably a category we won't include. Last but not least, Google also provides technologies that enable the automotive industry to build highly customized and differentiated solutions with their own user experience and branding. These are shown on the right-hand side on this slide. For partners that want to build their own custom navigation app and voice assistant for cars, Google offers 3 solutions. For custom navigation apps, we have the Automotive SDK and Google Maps Platform APIs. And for custom voice assistants, we offer the Automotive AI Agent, also known as AAA. The Automotive SDK is a headless offering that enables automakers to build navigation apps with their own unique design and branding. It gives partners access to Google Maps' full suite of search, point of interest, navigation, routing, traffic, map rendering, and other APIs, which can also be used to enable ADAS and autonomous driving systems and help with GSRA compliance. The Automotive AI Agent, or AAA, is a Google Cloud offering that comes with a reference application for Android Automotive OS. It enables automakers to build generative AI-powered voice assistants with their own user experience and branding. Which brings us back to Gemini. Gemini will not only be a voice assistant in cars that is much easier and more natural to use than the Google Assistant, it will also bring completely new capabilities to cars and act as an enabler for innovative new solutions. We are actively working with the Google DeepMind team to explore multimodal use cases for Gemini, combining both audio and video, and we are aiming to launch such a solution next year. We have a demo car outside that showcases some of the use cases this technology can unlock. Here's a short video that shows what Gemini can do with access to a front-facing camera in a car.
You know what building is this right in front of us?
That's Grand Central Terminal.
Actually, can you remind me the name of the bar and restaurant in this hotel?
The Grand Hyatt New York houses the New York Central Bar and Restaurant.
Can you read that billboard on the right-hand side?
The billboard says Wolf Paper and Twine Company.
What does this green road sign say?
The sign says Polizia Stradale and Controllo Elettronico della Velocità.
What is this colorful building that I see in front of me?
That is the Vista 99 apartment.
Did you see the name of the restaurant that we just crossed?
Yes, the name of the restaurant was Chimera.
What about this one? What kind of cuisine is it?
That is tandoori pizza, so it specializes in Indian-style pizza.
So as you can see, this is something we've been testing in real cars simply by rigging up a camera to the infotainment system with Gemini. An important factor for automakers who are interested in this technology is the electrical and software architecture in their cars that facilitates access to vehicle cameras via Android Automotive OS, which is crucial to support these emerging use cases. So if you want to support similar use cases in future, it's very important that you ensure that access to front-facing cameras and other sensors is available to Gemini via Android Automotive OS. We're also collaborating with SoC vendors to accelerate the use of Gemini Nano on SoC platforms. Gemini Nano is Google's smaller foundational model for on-device implementations. Our long-term vision is for Gemini Nano-powered on-device agent to be a fundamental component of next-generation voice assistants and to also support various non-voice applications. This approach will enhance offline capabilities, strengthen user privacy, and improve overall performance. Automakers will have access to a production-ready Gemini Nano model that can be deployed without additional tuning. Our initial test results are very promising, demonstrating accurate in-vehicle commands, along with superior query comprehension and natural conversation interactions. This also opens the door to new functionalities, such as on-device queries for the car's owner's manual. Please visit our indoor demos to see Gemini Nano in action, and we'll just show you a quick video now showcasing some of Gemini Nano's capabilities in the vehicle.
75 on my side, please.
Turning on the HVAC for driver.
Can you increase the fan speed by a little?
Increasing fan speed by a small amount.
Let's set the seat heaters to go all the way.
I set seat heat to the highest level for the current seat.
Beyond 2027, we're looking into AI assistants that can differentiate between passengers and can simultaneously interact with all passengers in the car using natural conversations. We have many other ideas as well, but as you're all aware, AI technologies are evolving so rapidly that it's not easy to predict what capabilities will be available 3 years from now. But looking at the nearer future, and starting with Android 16, a new app functions framework will be available for exposing and delegating app execution to AI agents using text or voice prompts. It's essentially a new Android mechanism for AI agents like Gemini to use capabilities provided by apps. You can learn more about app functions in a dedicated bootcamp session tomorrow. We at Google understand that every car is different and every automaker has its own unique product strategy. Google meets these varying product strategies with our comprehensive product portfolio to give each automaker and the industry options to choose solutions that work best for them. However, We acknowledge that the large number of solutions and possible permutations introduces complexity. The platforms and Google services that run on them also become more complex over time as new features are added. As the market demands faster development cycles from automakers at lower costs, software development for cars has been and continues to be challenging. Google is therefore committed to simplify the development and testing of Android-based software for cars to help the automotive industry lower costs and decrease the time to market. We're investing in new capabilities that simplify software development, such as Android Automotive OS's scalable UI. And we're investing in new tooling for developers to accompany our growing product portfolio and greatly improve software developers' efficiency. For example, faster Android platform development can be achieved with Google Cloud with cloud workstations running Android Studio and Gemini Code Assist and the Android build file system on Google Cloud. Faster testing to achieve Android compatibility can be achieved with CTS testing using Cuttlefish virtual devices on Google Cloud, build and partition reuse, and automatic build approvals and build exceptions. We also offer the Horizon Reference CI/CD platform on Google Cloud, which aims to standardize and simplify the code, build, test pipeline. We have dedicated sessions on all 3 days of the bootcamp where we'll be diving deeper into all of these topics. And that brings me to the 3 days of the bootcamp. This year, we have over 50 presentations, numerous breakout sessions, office hours, and demos. And all of the sessions broadly fall into one of the 3 categories that I mentioned earlier: platforms, apps and services, and enabling technologies, including tooling to make software development and testing more efficient. So choose carefully which sessions you'd like to attend, and don't forget to see the fascinating demos in this building and in the cars outside. If you don't know where to go, just ask a friendly Googler who's wearing a t-shirt like the one I'm wearing right now. And with all those upcoming sessions in mind, I'd really just like to close by encouraging all of you to spend as much time as you can with your colleagues here. The automotive expertise that's assembled in this room with all of you is quite mind-boggling and humbling. And we're all on this exciting journey together. So please use the opportunity to meet new people and exchange ideas. I, and everyone from Google, very much look forward to engaging with you over the next 3 days. Thank you.
Hey everyone, good morning. I'm super excited to be here, and we have a lot of people. So I'm Alankar. I'm a product manager with Google built-in team, and I'm here to share more about our plans to bring Gemini in cars this year. So a quick reminder, everything I share is confidential and it's subject to change. So with that, let's get into it. So our mission and vision statement continues to be the same. It's to deliver a helpful, personalized, and natural assistant in cars. And with Gemini, the capabilities that it offers, we make a tremendous progress towards this goal. However, car is a very unique surface. For example, for Gemini to be helpful in cars, it has to be safe. It has to be concise, it has to be factually accurate, and it has to account for contextual signals. For example, sitting in a car, if you ask, I'm feeling tired, you don't expect a response, close your eyes and take a nap, right? So we have to make sure that the models are tuned so that they are safe and they are very effective while you're driving. One of the goals of Gemini is to offer a very personalized set of journeys, right? It knows about the user, it learns about the user over time, so that makes it far more effective and productive. You could ask Gemini to summarize emails in the car. You could try to optimize your day while driving, while sitting in a car, in a very safe and voice-first manner. And last but not the least is natural conversation. It's unprecedented how immersive and engaging conversation you could have with Gemini. It's very similar to having a companion in your car, talking to a friend, talking to your partner while driving. So we'll go into each of those on the few next slides. So to deliver on this goal, we are investing in 3 investment pillars this year. The first one is vehicle specialization. So think of it as a user talking to the car. It's one of the most requested set of features from our OEM partners. They want capabilities, and we want to deliver a set of self-serve and scalable tools and platforms through which OEMs can highlight the unique capabilities of their cars to their users. So we'll talk about that. The other set is core user journeys. So when we ask our users that if we give you a magical next generation voice assistant, what kind of things would you want for it to do? And they still wanted to navigate to a place very safely and be connected with friends and families and be able to be entertained or be learning while they are driving. They want a very robust product in these areas that understand them, that understand their needs and meet those, fulfill those. So that's the second set of journeys. The third one we talked about, natural conversation, having the ability to talk to someone like you would to a friend or a family member. So let's go a little deeper into the first one, vehicle specialization. So again, as I said, this is an interaction between a user and their cars. They might be trying to learn or discover new capabilities of their car. How do I turn on seat massager? What kind of lights does my car support as ambient lights? They might be in a fix. On the side of the road, battery died. They might be asking, how do I jumpstart my car? There might be questions related to troubleshooting. Similarly, they might want to activate certain controls in the cars, and that all falls under vehicle specialization. These kind of interactions manifest in 3 forms. The first one is more open type of questions from owner's manual. So as I said, right, like for a new car, it could be as simple as what side of my car has the charging port, or where is the charging port located? Or you might want to see how do you restart the IVI of the car. And those kind of questions could be responded through user manuals. We already launched this feature last year, and it has seen a very strong user satisfaction rating since the launch. One thing is very interesting. I've rarely seen anyone reading owner's manual in one sitting like a novel, as entertaining as that might be. When a user asks a certain question, getting that answer in that moment is critical. So for example, last year around daylight saving time, we saw a strong spike in queries around how do I adjust the clock in my car. For 2 days, we have not seen those queries before or after that time. But for those 2 weeks, not 2 days, for those 2 weeks, it was the top of the mind of the users. It was very important for them to get an answer to that, right? And that's where the beauty of owner's manual answering right in the moment comes from. The second and third are kind of related. As more and more physical knobs and controls move inside the display, it gets more complex for the user. They don't know, first of all the controls, all the settings that are available to them. And while driving, if they start fumbling with the screen, it gets unsafe. So they want assistant to do things for them, but they don't always know what are the right phrases to use. All different OEM partners have a different proprietary name for their cruise control. Users don't always know what that is. So vehicle actions, vehicle display operation, it allows Gemini to perform those actions for the users. Both these capabilities are available to all of our OEM partners. Later this year, we would be adding Gemini capabilities to these flows. So users can ask these queries in a more natural way, and Gemini could still fulfill on those. So a little more information around some of these products. So owner's manual queries, owner's manual answers we launched last year. It's available in English. We are rolling it out in all the other languages. There are obvious benefits of using Gemini or Gemini capabilities in Google Assistant in cars, which is that you get upgrades to the latest Gemini models. There is a strong focus on quality. So we want to make sure that when you're asking a question from owner's manual, it's strongly grounded in the manual. The answers are concise, accurate, and relevant to the question. Like for example, in owner's manual, there are 500 mentions of Bluetooth, starting from how to pair my phone, how to activate Bluetooth, how to fix Bluetooth. Gemini does a brilliant job of understanding the context of the user query to get the right answer to a specific question, regardless of the variety of context that particular phrase might be included in the manual. Vehicle actions and display operations. We already have it available for our OEM partners. The focus now is to bring in Gemini, which helps with first natural expansion of the grammar. So it's not tied to some of the hard phrases, but users can be more flexible in what they want from Gemini. We also want to improve the scalability and self-servability of these platforms. So there would be a lot of focus on that. And then we will start improving the ASR and compound actions and so on. Vehicle specialization has been a top priority for us, and this will be a continued investment. So even after that, I think 2026 and beyond, we'll continue to bring in more and more improvements in this area. The second pillar is core user journeys. So while the first is where a user is interacting with the car, in contrast, this is where the user is bringing their life inside the car. They want to connect with their family. They want to find a restaurant or a coffee shop, and they want to navigate there safely. They want to be entertained. So they are continuing their life, inside the car, and that's where the core user journeys focus on. So most of the time, when I sit in a car, I'm going somewhere. And when we asked our users what is the most critical journey in the car, it's very obviously navigation. Imagine you are on a trip with your family, and you want to find some lunch options. Now, you have to make sure that that's a place where your wife, your kids, they all would find something that they like, right? You also don't want to lose a lot of time eating. So you could form a complex query such as, find me a Mexican restaurant on my way. It has to, it should serve kids-friendly menu and also vegetarian menu. Those kind of complex queries are very well understood and fulfilled by Gemini. You could also have a follow-up query saying that, are there public parks nearby? Or navigate to the one with minimum detour, and Gemini will find that particular option and drive you there. So very strong lift in the quality of interaction and the quality of user journeys when you interact with Gemini for navigation. Another complex set of queries is when it comes to messaging. Around 5% of messages that users receive in car are either long, or it's an outburst of small messages from a group chat. Listening to each of these messages individually and in their entirety is very tedious. So we launched message summarization last year, and again, we saw a very healthy opt-in rate, and we saw very strong user satisfaction rate for message summary. The other part that we are focusing on now is the drafting of the message. When you want to compose a message, it gets very tricky with all the noisiness in the car, Today, you have to draft a perfect message in the car. Today, you have to draft a perfect message in the car. With Gemini, you can give an outline of a message. So let's say you are running late from office. You could ask Gemini that, hey, compose a message telling my partner that I'm running late and share my ETA with them. And Gemini would compose that message. You can edit it. You could try to bribe your partner saying that, do they want to go for dinner? And the Gemini would edit that message. You can take a look, and then you can send it out. So in my opinion, this makes message compose, message reply very seamless and very easy to do while you are sitting in a car. The next one is media. A lot of times, users are in a car, they want to listen to something, but they don't know exactly what. So I might be in mood for jazz music, and I want suggestions for a jazz playlist. Or I might have listened to a book, and I want to find the next set of books, but the recommendation does not have to be a one-shot list of things. I want to actually know more about it. I want to go back and forth, tweak my criteria to find the next best listen for an audiobook. So Gemini can support all this. Sometimes you have this fleeting song where you don't know the title of the track, but you know that it won Grammys last year, or you know some of the lyrics. You can form complex queries asking that to Gemini. You could ask, could you play the song that won Grammys last year? And it would play it for you. So again, a lot of improvements in how people discover media while they are in car. The next one is natural conversation. And again, in my opinion, that's the most transformational change I have seen how we interact with voice assistants in car. So you sit in a car, you start Gemini Live, and you get this immersive and very engaging conversation companion. You could brainstorm idea for a perfect Mother's Day breakfast, or you could prepare for an interview, you could learn a new language, you could do all that with Gemini Live. The beauty of it is, the interaction is very human-like. So you could interrupt Gemini, you could change topic, you can just change your mind. It picks on the vocal tics like ums and ahs. It waits for your pauses and still grasps what you are saying. So interacting with, again, it's like talking to a friend or a family member. It elevates the experience from a task manager to more of a companion with you. So it's very impactful. And the transformation is not in the future. It has started. We launched message summarization. Owner's manual is generally available for all of our partners. Both of these products have seen very strong user satisfaction rate. This year, our team is already actively building core user journeys, such as navigation, media, messaging, vehicle actions, including Gemini Live. We have demo cars outside, so you are welcome to try it out yourself. The next year's roadmap is even more aspirational. We want to incorporate actions within Gemini Live interaction. We also want the users to have the ability of create custom media. You want to learn something about finance industry, or how to, you want to build an investment plan, and then Gemini can do that for you. Vehicle-related context, the perception, the vehicle perception with all the sensors and cameras. We saw some of the Astra-like capabilities as well. You could ask, would my car fit in this parking space? Or what was that signal, what was that billboard that I just crossed? And Gemini would be able to answer all that. So if you have not already, please reach out to your partnership manager to learn more. And we also have some early access programs for some of these features. So we would be happy to discuss more on that. With that, thank you.
I'll go midway and then we'll come from there.
Even though he introduced you, I'm still going to cue you and when to go.
Okay.
Hi, everyone. I'm Noam, and I'm excited to talk to you about our apps in car strategy and how we're growing the apps ecosystem in cars. So as a friendly reminder, everything shared here is under NDA, is of course subject to change. So like I said, I'm Noam. I'm the product lead for our developer platform, and I'll be joined shortly with Vivek, our technical program lead. And we're going to cover a few different things today. We're going to start with an overview of our app ecosystem, talk around the current state of the ecosystem and recent launches and wins, go over our plans and strategy for the future, as well as how do we engage developers and how do we improve their ROI to really encourage investments. So let's start with the overview of the app ecosystem in cars, and what is our approach to it. So Android as a whole encompasses a lot of different devices and form factors. And one thing that we're seeing recently in Google is that there's more and more emphasis on large screen form factors. So think of tablets or foldables, laptops, and of course also cars. So that gives us really a good opportunity to grow the app ecosystem because that is the direction that apps are going, and that's the direction that Android is pushing app developers. So for cars specifically, our mission is to create a robust automotive app ecosystem where developers flourish, users are happy, OEMs grow, and Google's platforms really shine. To achieve that, we're relying on a few principles. The first is that we want to reuse constructs and patterns from mobile and other large screen devices as much as we can. This helps us maintain a consistent ecosystem for developers. It really simplifies the developer story. But we also want to make sure that we're optimizing for safety first in cars. At the end of the day, cars are not a mobile phone. So there's different requirements there. And even though we do want to scale up the ecosystem and have more apps, it's still secondary to safety. It's also really important for us to harden the platform. We want to create a very strong and stable base for developers that they can create delightful and excellent experiences on top of. If they can't rely on that things work in a consistent manner, it's very hard for them to come up with new features. And lastly, it's important that we minimize developer costs as much as we can. This really increases the developer ROI, and again, encourages investment, encourages more apps. So I kind of mentioned there's a lot of different devices, which means there's also a lot of different apps out there on Android. So what apps are actually useful in cars? There are millions of apps overall in the Android ecosystem. Not all of them are actually useful while you're in the car. So when we look at data, we see that generally apps that people use in cars, and that could be not just in the car, even on their phone, fall into three clear categories. We have navigation apps, entertainment apps, and communication apps. Now, not all of those are useful while you're driving. Some are more optimized and useful while you're parking or maybe waiting for someone. And some kind of cross the boundaries between driving and parking. They might have some user journeys that are useful when you're driving and others while you're parking, all in the same app. So I mentioned there's millions of apps in the Android ecosystem. And even though some are more useful in the car, why can't we just bring all of them? Now, I think that's a good question. But we have to remember that at the end of the day, cars are not a phone, like I mentioned. They're also not a tablet, even though they have a big screen. So that means that not all the capabilities that an app expects to be on the device are present in cars. So maybe the car doesn't have a back button or access to rear or front cameras, and apps expect that. That means that if we want to bring those apps, we need to have some sort of compatibility mode to make sure that they don't have any unexpected errors or any other crashes. I think it's also important to remember here that for many users, the concept of a car that is a smart device that has apps in it is still relatively new. We want to make sure that they have a really great first experience with those kind of devices. So that means that we want to make sure that the apps that they see in the Play Store are relevant and have a reasonable reason to be in a car, and also have a very high quality bar. With millions of apps out there, Not all of them are like the best apps or the most useful or really fleshed out. And we really want to make sure that what's available in the car is really good. We want to scale, and we do aim to scale the ecosystem rapidly, but we're still mindful to value quality over quantity at this stage. The other thing that's important here, especially as we grow the ecosystem and scale it up, is that we need to have a tailored Play Store experience. We couldn't just bring the Play Store as it is from a phone or from web into cars. So some key highlights and changes that we have in the automotive Play Store is intelligent app installs. So that means that while apps could download or update, or download the update while you're driving, we don't want them to install immediately, because that could cause a reset in some processes or some changes if it's an update. We don't want anything unexpected to happen when you're driving. Cars are also parked often, though, and sometimes they're parked without anyone in the car. So we have optimization going on to make sure that things are downloaded when appropriate and installed or updated when appropriate. We also have a bunch of features around cross-device handoffs and cross-device discovery that mean that you can find apps on your phone that fit for your car and initiate the installation and the updates from your phone, or maybe continue some journeys like payments on the phone where they might not be as easy or as intuitive on a car. It's also important for us to empower OEMs to make sure that you can decide specific apps that you might want to pre-install or recommend in the Play Store. We also have kind of smarter recommendations for apps that fit cars and are better and more useful for the given user. So now that I covered a brief overview of what the app ecosystem is in cars, I want to go over what's the current state of the ecosystem and some of our recent launches and wins. So where are we today in apps? And something that's important to mention, I said that we want to have a high quality. One of the ways we're maintaining this high quality is with having clear guidelines and requirements for developers, depending on the category of app they're developing. So if you're building a media or navigation app, we have strict requirements on what you can do or can't do to make sure that the experience is both high quality and safe for users while driving. As categories mature, we move them from beta, which is when we're defining those requirements and validating with a few trusted developers that they work as expected, to general availability, which means that any developer whose app meets our guidelines and requirements could publish them to the Play Store without us having to be directly involved in it. So recently, we're opening up more categories and transitioning them from beta to mature, both on Android Auto and on Google built-in. Some are easier to do in others, and therefore they're not always aligned, but the goal is to have everything on both platforms. So recently, we've added video apps into Google built-in. We have games in beta in both of them. And our aim is to bring more categories and mature them as fast as we can. And something that is really exciting for us is that we actually grew the ecosystem by a lot in the recent years. Last year alone, we've grown by over 50%. And those includes both new flagship apps, so those are apps that are built for the car, as well as car-ready mobile apps. So car-ready mobile apps, also known as Karma, you might have heard that term before, are apps that were actually built for phones or tablets, but they do work well on large screens, except that there might be some features that are missing, like I mentioned. That's why we have a compatibility mode that kind of bridges those gaps, make sure that those apps would work really well on cars. We extensively test them before enabling them. And so far, we've launched around 100 apps already. And we're bringing more every day that we're testing and kind of adding in batches. And then we're also having Karma Phase 2, which we'll talk about later, that will bring hundreds more apps as well. We're going to have both more details in this talk today and a few dedicated talks later in this week as well, if you want to learn more. So with all of this great growth, I'm really excited to share what is our plans for the ecosystem to take things even further, both to have better apps and more apps in the car. So we're focusing on 3 key goals when we think of apps in the car. The first is one, we want to have bespoke and differentiated experiences. So we want apps to leverage unique capabilities that the car might have, whether it's having more speakers or having a cluster, or the fact that cars both drive and park and have transitions between those two, depending on the user journey. But we also want to make sure that in addition to those really top-notch, excellent, delightful apps, we grow the overall app ecosystem. We want to make sure that users find all the apps they look for in cars and have more and more use cases that they can leverage in the car. So we want to unblock developers at scale. This is where the Karma program comes in. And this lets us scale with hundreds of more apps very quickly. And what really powers both of those goals is to make sure that we're improving our developer ROI, making it easier for developers to build things for cars, making it easier to publish and test on the car, and overall make it make sense for developers to want to be in the car. I want to highlight here that there's a bunch of different categories. All of them are very useful in cars. But the recent focus for us, and it's going to be in the foreseeable future, is the entertainment space. And there is a few different angles that we're approaching in this space. We want to make sure that we're growing the app catalog, have more entertainment apps. And entertainment could be media, it could be games, it could be movie streaming. And we're seeing a lot of growth here. This is where the Karma program really shines. There's a lot of entertainment apps out there in cars. They are anyway mostly useful when you're parked. So it's a perfect fit. But that said, we do want to have car-specific features. So those could be new in-app experiences. A lot of media apps, like Spotify, are innovating with new features. We want to make sure that they're also in the car and not just on the phone app. We also want to have other unique features, like being able to to listen to videos while you're driving, even if you can't watch them, supporting Google Cast, things like that. And lastly, we know there's more and more use cases. And as the overall industry moves forward, we want to make sure that we have strong support for things like multi-display or whole cabin experiences where media would really shine. So you might have seen a slide like this before, both in our I/O talks and I believe also last year's Partner Bootcamp. But our overall strategy to apps in cars is looking at apps in different tiers. Not all apps are created equal. Not all of them have the same motivation to be in the car and the same usefulness for users as well, and the same expectations. So at the very top, we have what we call car-differentiated apps. Those apps are apps that really create the most delightful, most unique experiences out there. They kind of leverage the cutting-edge new features that we and OEMs enable in cars, and really create this experience of, wow, this is so much better than just using my phone or projecting apps. We don't expect to have many of those apps, right, in the orders of dozens of apps. But those are the developers where it really makes sense to be in the car. So think of music apps, think of navigation apps, stuff like that. Next up, we have the car-optimized apps. So those are apps that were built specifically with cars in mind. They follow all of our guidelines and requirements. If it makes sense for them, they could be used while driving because they follow our safety guidelines. And this is the bulk of the apps that right now are on the Play Store. And our goal here is to really grow that baseline, encourage more developers to build for cars. And further down in the chain, we have our car-ready tier. So those, like I mentioned, the Karma apps that were built for tablets, built for mobile phones, but do work well in cars. And we know they're a good enough high quality such that users will enjoy them. And this really allows us to rapidly grow the type of use cases and type of apps we have and kind of make users really realize the potential and how many different things they can get in the car. And of course, there are millions of apps in the Android ecosystem, right? So there's more apps that we don't really think should be in the car, either because they're just incompatible in terms of features that they need, or just they're not relevant use cases. We don't really believe that users will really need or ever want them in a car. And therefore, we're not investing a lot in testing them and making sure that the quality would work for them and bridging the gaps there. So with that, I'm going to dive into the specific goals and how are we planning on actually achieving them. So we'll start with growing our flagship apps. I think those are the most important apps. Those are the apps that users engage with the most in cars and really highlight what the car can do. So when I say those flagship apps, I don't just mean that pinnacle of great apps. I also mean car-optimized apps, apps that were built for cars. and we have slightly different approaches to either of them. For those optimized app, we want to encourage developers, make it easier for them to build it, get more apps that were built for cars, and really kind of emphasize and like work and show how the car can really shine. But for the flagship app, the top tier 1 apps, that's where we want to add more features. We want to make sure that every feature that the developer wants to build and want to innovate is possible for them. So we're constantly adding support for new, unique capabilities there. We want to make sure that apps will never lag behind their kind of phone counterpart. If you're Waze or Spotify and you're adding new features into your phone app, users also expect to see them in the car, because those are apps that are most useful in the car. So what kind of unique capabilities am I talking about here? So those are things like cluster support for navigation app, which really create a more immersive experience, but also safer experience, and kind of add to that wow factors for user. I'm talking about things like audio while driving. So something that happens to me quite often is that it happens that my commute back from work is when there are Lakers games that I want to watch, but I can't watch them because I'm driving, and that's not safe. But wouldn't it be great if I could at least put them on and listen to them in the car as I'm driving? So that's like a new capability that we're bringing. We also want to have more and better experiences using our car app library. That's CAL for short. You've probably heard it before. That is our framework for developing apps to be used while driving in a safe manner, in a way that kind of adapts to different screen sizes in the car and the different input modalities. And we're encouraging more types of apps to be able to leverage CAL. So we're bringing new categories like communication to it soon, as well as opening it up for media apps. And this is how we're going to allow those top developers to bring all of their exciting features from the phone quickly into cars in a way that's easier for them to iterate and easier for them to update and launch quicker. Other capabilities here are ways to discover content, especially as we bring more and more media apps into car, especially if we'll have things like multiple displays and passenger displays. We want to make sure that users can find all the content they want. You might have already seen things like that on like TV, for example. So those are ways to really encourage users to engage more with the content in the car. There's more and more games in cars now, and sometimes it's not as easy to play on a center display that might be a bit far from you or kind of centered, not centered to you, but centered to the car. So those are things like controller support for games, so it's easier to play. And again, like making sure that media works really well on multiple displays. We are going to have a few deep dive sessions later on this week. We're going to have one for Car App Library that will talk about how it works and what new features we're bringing, as well as a session dedicated to media in the car and kind of what innovations we're bringing later this year. So with that, I'm going to hand it over to Vivek, who will talk more around how we're unblocking apps at scale and how we're optimizing for developers. Vivek?
Thanks, Noam. Hey, everyone, I'm Vivek. I'm a TPM lead with the Auto Developer Platforms, work with a lot of developers to bring apps to cars. Noam covered a lot of topics around how we are engaging with developers and motivating them to build for cars. But there's a lot of things that we can do, and I say we, it's like Google as well as OEMs together, to make sure that we can unlock those capabilities in the cars as soon as possible and bring more apps to cars. So shifting gears, so Noam covered the car differentiated and car optimized experience where developers are invested to build for cars. But he did touch upon the Car Ready Mobile Apps program, which is basically mobile apps available while parked, running in AAOS in a bit of a compatibility mode. So I'll touch a bit upon what we've done so far and where we're heading on this direction. OK. So we introduced the Car Ready Mobile Apps program in 2024 at Google I/O. Since then, we've launched in February 2025 about 100+ apps. And this year, again, we re-emphasized the importance of the Car Ready Mobile Apps program. Our goal over here is that as a developer, there is zero development work in the context of cars. They've built a great Android app, and that can just work out of the box in the car. And if there is any issue that is specific to the car that's not on their phone or tablet app, then it's on the platform to make sure that those compatibilities are addressed. And once these apps enter the ecosystem, we believe that they'll be more invested once they get user feedback. They'll be more invested once they get usage within cars and start investing and going above the tiers that we spoke about. So as I said, our goal is to support a high-quality compatibility experience. Karma Phase 1 launched with support on Android Automotive OS 12+, and we have 100+ apps launched. That being said, we don't want to stop at 100. We want to go into the thousands. And to do that, we have added incremental compatibility starting AAOS 14. This is being referred to in our help center docs as Karma Phase 2. But what we're doing over here is we're bringing the same compatibility that's available on tablets and other large-screen form factors to the car. The goal over here is that apps that work well and people use on their tablets, they expect those to also be seen on a big screen in front of them in a car as well. This will be available, as I said, on Android Automotive OS 14+, and for gas OEMs would be required with Android Automotive OS 15. This is just a high-level summary of how we are going in this direction. There are more detailed sessions around each of the features that will be part of this compatibility within AAOS. So please do check out those sessions lined up in the next few days. Shifting gears a bit, we touched on the different programs and different types of apps. So here, what we want to focus on is how do we bring these features to market as soon as possible in a way that's most predictable for developers who haven't seen these cars, who haven't seen what different screens and what different systems look like, and with the tools that they're familiar with. At a high level, the goal is find the developers where they are and then get their apps to cars. And we've been investing a lot over different years across the different stages of the development in cars. We know that it's a challenge to keep up with pace with mobile for the car ecosystem. So Google's taking up the cost of making sure that we are giving opportunities in all different ways to get the broadest coverage for apps within cars that are already on the road, so you can OTA additional capabilities in terms of patches, as well as new programs that you're building, make them part of your considerations early on, so that when you launch, you have the best suite of apps out of the box. So what does that look like? So one way is that Google works closely with early access GAS partners. Typically, it's a lead partner that works closely with us. We will establish a relationship on a set of guidelines and requirements, along with some compliance tests that we will provide with a reference that Google builds. Work with the OEM, make sure it's scalable, and then go to stage 2, which is just make it part of gas requirements and ATS tests. This way, any gas OEM that's taking up these patches can roll out and unblock these set of apps within their programs. But we will not limit this to just gas OEMs. We want to make sure that the overall Android automotive ecosystem can grow. So all of these requirements are then part of AAOS patches in the main lines and future releases, as well as CD and CTS tests that we include so that the next AAOS build that you build is compliant out of the box. But that covers just the part that's part of the OS. We also have a lot of Google Play services that come with the gas cars. The beauty of these is that you don't have to wait for an OTA. You just need to be connected. So as long as you are connected, we are rolling out a lot more Google Play features in the cars that support app experiences. In the past year, we launched over 12 new modules, some of them unblocking key experiences like games with like Play Game services, as well as we are lining up some great experiences to come to cars like Quick Share in the coming few months. To make sure that there is a strong standardization and predictability for developers, we are ensuring that we have different certification programs. You may have heard of NDO certification before or Karma Phase 1 certification, but this is the model that we've been using to unlock a bunch of apps that, if the system is compliant, can went through the Play Store. And there's more to come as well. Once these are made available for OEMs and the certifications are in place, we start taking this back to developers. And these can be possible to their touch points, which is developer tools. So we invest in emulators that are compliant with these patches, that are compliant with these certifications, and they roll them out across the different types of screen configurations that we have, as well as physical hardware with like AAOS on Pixel tablets. Post that, we also make sure that the play workflows are adjusted so that as a developer, they're able to easily distribute to cars, as well as we can make sure that the right compliant system is targeted with the right set of apps that are coming from the Play Store. And the story does not end with just Google trying to support this. We also need to make sure that OEMs are able to contribute and get their latest versions of the emulators to developers. As you can imagine, for a developer that has never seen these cars, the closest way for them to experience their app experience is on your cars would be on an OEM emulator today. Emulators are the closest tool that developers can use to troubleshoot issues. And this has been like a pretty highly requested feature from developers, just to see like, wait, what does my app look like? And we continuously encourage OEMs to roll out new updates and new versions of emulators that are more compliant with these features. So we saw a lot of, a bit of the workflow of how we operate and bring new features to cars across different Android branches, across different gas OEMs. But there's a continuous investment from our side to improve the developer ROI. This investment is not just from Google, but it's also with Google in partnership with OEMs. So let's look at some of the ways in which we can start addressing the ROI for developers. The first one is we need to demystify the car infotainment for developers. What developers see on the road and in commercials is a bunch of screens, different shapes, different sizes, not something that they're used to when they work with any other form factor. Also, the uniqueness of the car is that it's not just the shape of the screen that's different, but it's also cars have different insets, different cutouts of sizes that developers are not used to in other form factors. Thirdly, these screens are not standardized by distance. Unlike a phone or a tablet, if you don't like it, you just get it closer to you. You can't do this with a fixed screen on a car. And lastly, it's early days for the ecosystem. Like handling fragmentation and adapting to these features is something that developers don't think about. They either think about cars or not cars. They don't think about cars on a version of Android or a version of like gas and so on and so forth. So here's some guidelines that we have. These are not really certification, but just some tidbits that we have observed on the ecosystem from OEMs. So first one is like system display density. We picked up a bunch of OEMs and like tried to measure what their system density looks like. So for a 48 by 48 dp touch target, we noticed that most of the OEMs have a touch density that's similar to that of a mobile, and not even as a tablet. What we would then like to recommend is that when you build your system and design what the visuals of the system looks like, you as the OEM know how the screen is going to be, how far will it be, and so on and so forth, and take that into consideration when defining the default system density for the ecosystem of apps. We typically recommend somewhere between what a tablet would have to a little larger than tablet, which is like 8 millimeters to 12 millimeters for a 48 by 48 dp touch target. Second is having canonical display for apps. This is pretty straightforward. When apps are running, you want to make sure that if it's a portrait screen, it's close to an aspect ratio of a portrait device. Similarly, if it's a landscape screen, when the apps are rendering, it's closer to the aspect ratio of a landscape device. We also see cars with hyper-wide displays. So in those scenarios, you want to make sure that the shortest width of the screen is higher than 600 dp. And lastly, minimize insets and cutouts. It is always challenging for developers to handle them, especially if they are pretty big. And the more cutout the experience is, the less premium the app experience looks like within the car. And last, this guidance that I think is across the board. OTA periodic updates and update to newer versions of Android. There are a lot of features and patches that we roll out continuously in the mission to engage developers and to bring them to the car ecosystem. So ensuring that you are able to roll them out with patches, bug fixes, and new features. We'll make sure that both the cars on the field and the new cars that are coming out are part of the developer's mind space when they are building for it. So what is Google doing for that? We have initiated some new certification programs with the goal of shipping with high quality. You'll hear more about it, but we have introduced a new certification program for Karma Phase 2, one that I spoke about that will bring you thousands of apps well parked. And it's going to be available in tests on ATS for gas OEMs, and the help center, et cetera, has been published today. Secondly, we are working on introducing top app CUJs. CUJs are critical user journeys. So we are working closely with these developers to identify what are their key user journeys that they care about in the car, and then introduce them as radar-based tests so that as OEMs, you can verify them and make sure that they look well and work as expected before you ship out these experiences. This is more to give both you as well as the developers the confidence that when the ship of the build sailed, everything looked great and worked as expected. Lastly, we're also moving car app library certification into ATS. We're going to migrate the current manual-based certification tests to a more structured ATS-based program. So you can use the same certification tools that you're using for other certification programs on gas for car app library as well. This will scale as we add more capabilities to car app library. As you heard, we want to unlock richer experiences from developers. And in order to do that, we want to make sure that the platform has those capabilities and those experiences so that those templates work beautifully when the apps use them. As I said before, Google is continuously investing in bringing these developer tools on the surfaces that Google owns. So we already have released, as of Google I/O, a fully certified Karma Phase 2 emulator with all the features that we spoke about, as well as a fully certified Karma Phase 2 Pixel tablet with AAOS image. For what it's worth, this has been one of the most requested features and most consumed features by developers, as it makes it really easy for them to play around on a physical device and even keep it at a distance that a car infotainment would look like. Lastly, and this is new, we are also bringing automotive hardware from our references to Firebase test labs. So this way, as a developer working on Android Studio, where they work with other devices connected to their development environment, they can also now connect to Firebase test lab, get automotive hardware, and run automated tests or remote access-based tests as part of their building experience, as well as use play pre-launch reports as part of their deployment and release experience. This is also not just limited to Google tools. We also want to encourage OEMs to invest and be part of this evolution. So obviously, we spoke about emulators. We would like to have certified OEM emulators so that developers can can test their experiences on them. Google will be happy to support bringing them and surfacing them in the right areas. But in addition to that, we also want to make sure that our bug triaging and reporting mechanisms are great. So we have a new bug reporting tool that we have introduced for OEMs to distribute as part of their dog fooding and team fooding vehicles. This allows both OEMs as well as Googlers to report issues, triage them quickly, even while you're driving on the road, and do it in a safe and seamless manner for ourselves as well. This has unlocked a lot of issues for us to even troubleshoot, and we strongly encourage OEMs to make it part of their build so that we can increase the flywheel of quality across the app ecosystem. Lastly, Firebase test labs are also being extended with OEM hardware. We already worked with a few OEMs to be part of the early access program, and we encourage more OEMs to connect with us, learn about how to include their hardware, not just for app developers, but also for your own developers through Firebase test labs. To learn more, we have more sessions around the bug reporting tool that I spoke about, as well as labs at scale. There's a session around it, as well as some more demos. And definitely, we have a lot more demos and indoor demos in the building over here, covering the Karma, the latest features around them on both Android 14 and 15, a bunch of development and testing tools that will unlock more apps. as well as we have a bunch of in-car demos showing both a Google reference in action, as well as a Volvo EX90 with AAOS 15. This is an early preview. It's what we showed at Google I/O. So do take a stop and check them out. We touched upon a lot of topics over here, and it's a very high-level overview of what our app ecosystem strategy looks like. Thank you for your time and for your patience to listening to us. Obviously, if you have more questions, Noam and I will be around for the next 3 days. And for those who are online, you can reach out to us over email. But these are exciting times, and we are committed to drive and rapidly evolve the app ecosystem for cars in partnership with all of you. Thank you.
musique me fait vibrer. Elle me donne envie de danser. Oh, les vibes sont tellement sensuelles. New York, je t'adore.
Good morning, everyone. I hope some of you lucky few got some coffee. And welcome back. It's a privilege to be here with you this morning. As we look around, it sort of becomes clear we're in the midst of, a revolution of sorts. Where our vehicles are transforming from mere modes of transportation into sophisticated, connected living spaces. And at the heart of that is something we find deeply personal, something that drives emotion and a connection of a different sort: music. Imagine every drive, every commute, every road trip seamlessly soundtracked by your own world of music and podcasts. That future is not just within reach. We think it's here with YouTube Music. A quick reminder that everything we speak about today is confidential and subject to change. My name is Dan O'Mara. I'm an engineering manager at YouTube Music. And along with Jen Louis, who unfortunately can't be here today, we lead the team responsible for building integrations with our partners' devices and applications. And at YouTube Music, our mission is clear. We're here to cultivate and deliver your world of music and podcasts. So let's take a moment to break that down. The delivery part, well, that's table stakes, right? The bits have to flow, the music has to play, right? But it's the cultivation that we think really sets us apart. It's not just about making accessible millions of songs. We help users and you discover new content and then foster and grow your relationship with that content. So the experience, well, it really gets to your heart. Now that sounds cheesy, even as I say it, but every time we do user research, we're reminded about how emotional the experience of listening to music is, and fandom, and how meaningful this is to our users. And finally, your world of music and podcasts. This isn't just about our untouchable corpus of content, but also about the other fans around that content, both on and off the platform, and this real living ecosystem of content and community thriving together. So today, I'm here to speak with you about how we can deliver that cultivated, communal, and utterly personalized experience to the heart of your vehicles. We'll explore the unparalleled value of YouTube Music, the innovative ways that we're leveraging AI, and most importantly, the practical and flexible pathways for you to integrate with YouTube Music. At the core of our offering is something we call the best deal in streaming, which is the bundle, the YouTube Premium and YouTube Music bundle. For one competitive price, users get 2 powerful applications. So that's ad-free listening, unlimited music downloads for offline consumption, and background play, so the music doesn't stop, even if the user's screen is locked or they're using other apps. And of course, this extends across all of YouTube as well. So we're giving users something for their money that other premium music service providers simply can't do alone. And it's not just about this deal. We're also bringing a huge community of deeply satisfied users. We were very proud to recently announce that YouTube Music across YouTube Premium and YouTube Music Premium boasts now 125 million subscribers. And even more importantly, there's our Net Promoter Score, or NPS. Here, we're asking users how likely they are to recommend our app to friends and family. We subtract the not likelies from the likelies, and we get the net score. And YouTube excels here. It's a powerful indicator of user love and loyalty, and we see that we're outperforming our major competitors in the global space. Matching this incredible user base is an equally incredible library. We offer access to over 100 million tracks, an unparalleled audio experience. But beyond that, we also provide access to hundreds of millions of other content types you won't find anywhere else. Live performances, DJ sets, gaming soundtracks, long live streams, behind-the-scenes content, and so much more. And yet, users tell us they find this kind of lonely. Sure, there's the creator-fan connection, but what about all your fellow fans? YouTube Music is the only major global service provider that supports comments. And we see that comments is a hugely meaningful platform to talk about content that users love. They springboard off comments to find and subscribe to fellow music fans, and then also create new spaces where users gather together to discuss artists, genres, podcast shows that they love. Now, how do we make this content even more intelligent and personal for, say, a driver? Well, that's where our cutting-edge AI integrations come in. Gemini and YouTube Music is transforming this consumption experience. We're finding large language models to be incredible companions to music consumption. For example, our Ask Music feature. Imagine you're driving and you know the vibe of music you want to listen to, right? But not perhaps the specific song or artist. With Ask Music, in natural language, you can describe what you want to hear, and YouTube Music will create a tailored radio for you. So you could say, hey, play something upbeat for my morning commute. Or, I've got a long trip ahead. How about some relaxed jazz? And of course, it's not a one-and-done command. We support multi-turn navigation so that you can modify your session. Perhaps you can say, actually, make this a little more chill. Or, you know what, scratch that, I'd like to hear some vocals. This level of conversational control in a car is paramount, where voice interaction, of course, is not just a convenience, but a critical safety feature. Other Gemini capabilities also enhance the experience. Do you need a unique image for your amazing new playlist? Gemini can help make you one. Do you want to understand the vibe of mix number 4 that YouTube has created for you? It turns out that a user is far more likely to listen to a playlist named Hyperpop Dance Party than they are My Mix number 4. You can also create YouTube Music playlists with Gemini, and we're actively investigating even deeper integrations so that Gemini is aware of your library and your tastes to make even better recommendations. And we're working on richer features for cars, ensuring that the intelligent, personalized experience of YouTube Music becomes a standard part of the driving experience. Okay, so our technical vision is simple. Music everywhere. YouTube Music needs to be there no matter where you are or what you're trying to do. And we're making good progress towards that. We already have a diverse and growing portfolio of device integrations. You'll likely all be familiar with the Android Auto Projected or Android Automotive OS for Google built-in applications that we have. And over the past couple of years, motivated by these reach objectives, we have begun to support other solutions to enable access across more device types. A prime example of that was our first partner-developed integration with Tesla. This was a pilot of the YouTube Media Connect API, which I'll get into a little more detail on shortly. And remarkably, this client was built in 8 weeks and a full quarter ahead of schedule. We have also significantly expanded across other categories, such as wearables. And over the past couple of years, YouTube Music has launched integrations with Fitbit smartwatches, Wear OS devices, including Google's Pixel watches, and a growing number of Garmin models, which first launched last June. Okay, so let's talk about the various ways that you can integrate YouTube Music into your automotive platforms. We recognize that every OEM has unique needs, varying levels of desired control, and of course, different timelines. Our platform offers 3 primary ways for integrating YouTube Music, each providing a distinct level of control and ease of development. Our aim here is to elegantly balance our partners' needs for control and composability with speed and efficiency of deployment, and of course, with delivering high-quality user experiences. So our offerings reach from the eminently composable REST API to templated, customizable applications for AAOS, to mobile applications, more tightly coupled with YouTube's own applications for iOS and Android. Okay, so first we'll dive into the API, right? This is our solution for maximum flexibility and customizability. What is it? It is a REST API, and it offers you, as a developer, full flexibility in building and deploying your system's YouTube music experience. It is fully owned by you. A key advantage of the API is it provides data. It is not opinionated about rendering. It delivers intuitive resources, understandable concepts like tracks, podcast episodes, playlists, and queues. So the partner developer has complete control over the user interface and the overall look and feel. They can develop a client consistent with their own design language and brand identity. And it has proven hugely successful. As mentioned, partners have completed integrations with YMC in a matter of months. It offers all the table stakes features you might expect. Searching for YouTube music content, retrieving metadata about artists, tracks, playlists, getting music and podcast recommendations, controlling the playback, of course, and downloading for offline consumption. But it's not all about consumption. We've also added new capabilities to enable curation by the user, creating and modifying playlists, accessing the queue items, support for user-owned uploaded content, and of course, accessing the user's recently played tracks and podcast episodes. As a short aside, the same API has been used to enable an exciting collaboration with Apple Music. The data transfer initiative enables portability of a user's playlists from one service to another. And we have similar partner integrations on the same technology with companies like Tune My Music. One of YouTube Music's core strengths is the recommendation engine, and the API, as well as our other solutions, surface this power. But extending to third-party devices with various form factors and capabilities is complex. And YMC takes that integration type as context, along with some optional API parameters to determine the complexity of the responses that it will serve. So this means simpler linear feeds for small screen form factors like smartwatches, and more configurable page sizes and shelf depths with continuation tokens for pagination for those higher resolution or larger format user interfaces such as those in your cars. Partners can connect a wide range of capable devices, effectively anything that's internet connected. This is our platform utility knife. As long as you're a platform that doesn't have an existing YouTube Music client, then you likely can integrate with this API. And similarly, the API approach offers great flexibility in terms of application architecture, and we already have a number of different models in production. Direct deployment of an API client binary to the device, as is the case with Tesla or the Garmin smartwatch. We have cloud and backend services negotiating between our API and the device's own SDK or interface, such as with Apple HomePod, and even the hybrid models, if you will, including cases where we have mobile and audio device integrations working together to negotiate browse and handoff for playback, as we'll see in an integration with LinkPlay's Weem smart speakers, which are coming soon. Okay, quickly on to Android Automotive. So for many years, our team has offered Android Auto wired or wireless projection from mobile clients, and of course, AAOS with GMS Core for GAS and Google built-in. And today, we're witnessing a clear momentum for Android operating systems in the automotive sector through both Google built-in and notably the adoption of the Android open source project. And so this year, we'll be launching a new AOSP compatible application for AAOS. Now, both our Google built-in and AOSP solutions are templated media applications. They leverage the Jetpack Media 3 APIs, and so they offer that standard architecture with opportunities for customization. YouTube Music takes care of authentication and settings. We implement the media library service for search and browse and recommendations, as well as the player. The OEM partner implements media browser and media controller, giving you control over the look and feel of the user experience. For distribution, we'll control a registry of build artifacts for distribution, very similar, analogous to the Play Store and the Google built-in format now. And we can establish these relationships either directly with OEMs or via OEMs' preferred partners, and work with each of those entities on certification, testing, configuring releases to specific end-user models, etc. And our commitment to partnership with you goes well beyond the code. So as we're introducing these new improvements, features, platform capabilities, we're working to eliminate friction for developers, removing tedious workarounds, removing the need for boilerplate application code through a comprehensive suite of documentation, tools and reference applications, test and inspection tools, and obviously well-documented certification requirements and UX and brand guidelines. So thank you. The future of in-car entertainment, we think it's vibrant, we think it's intelligent, and we know it's deeply personal. So by integrating with YouTube Music and integrating into your Android and other automotive platforms, you're not just adding another streaming service. You're unlocking a powerful and beloved entertainment ecosystem for your customers and giving them the ultimate soundtrack to their drive. We're super enthusiastic about the opportunities that lie ahead. We're committed to partnering with you to bring this vision to life, and I look forward to speaking to you all about it over the course of the next few days. Thank you.
Good morning, all. It's a privilege to be here. And in this session, we'll be talking about YouTube Main in connected cars. And before we dive deep, just a quick introduction. I'm Nishant Mortwani. I manage global automotive partnerships for the YouTube team. Now, in this session, we'll be broadly covering three key areas for us. First, the market opportunity. Automotive is still a new landscape for us, and we'll be highlighting how we think about this vertical both in the near term as well as how we see it evolving a bit in the longer term. And secondly, well, we're still making our presence in this automotive, so we're still facing some challenges as well as issues that we'd like to highlight, and opportunities where we can really do better, enrich our user experience, scale better. And lastly, we'll also talk about a couple of technologies that would help create even richer experiences that we would like to see the industry adopt over time, and conclude with how automotive OEMs can partner with YouTube in this space. So let's start with the market opportunity. Like we said, automotive is still somewhat a new landscape for us. And while we have launched some experiences in the space over the last few years, it's still very much a beginning. Understanding the opportunity and challenges will help us scope out how to approach automotive today and over the next few years, which includes aligning both with our stakeholders internally as well as externally, such as partners and integrators. Now, if we go back to CES 2023, automotive really seemed to have its pivotal moment. The heavy focus on automotive at the event was relatively recent development, and up until this year, the industry has really stood apart. And there was a lot of focus on cars, electrification, and sustainability. And the auto industry's main focus was on electric vehicles, followed by autonomous vehicles, infotainment, connectivity, system components, and maps. And this has basically created a new perspective for us in that cars, much like any other consumer electronic device that dominated at CES, have now become a technology product. And as such, this presents more opportunity for infotainment systems to integrate entertainment options. And as vehicles become more connected and capable of streaming content, we see this adoption going up. Now, most of you are already aware of this. The auto industry will continue to become more and more connected, enabled by a number of factors. So let's talk about connected first. Most of the new cars rolled out today are already somewhat connected. and with higher adoption for both 4G as well as 5G, we see this growing and enabling better bandwidth to support more data-intensive services. Now, when we couple this with autonomy, electrification, and even increase in ride sharing, we see that there's a huge increase in more idle time within vehicles for both the rider as well as the passengers in this particular case. And even in the US, we've seen that an average person can spend more than 1 hour per day in the vehicles. So therefore, we see entertainment solutions, both audio and video-centric for connected cars, becoming a necessity. And so YouTube's been actively engaging across many of our automotive partners and integrators in finding the best path forward for our applications. Now, before we dive into our kind of challenges and some of the current issues we're seeing in this industry, we want to still say that automotive is still kind of new. There's a few things that affect how we deploy in automotive. And we're learning a lot from the partners we're working with in this space as we increase our engagement with more and more OEMs and solution providers. And our North Star is to really kind of ensure ubiquitous solutions that users are already familiar with in other devices and how we can fit them into the automotive context. Now, again, before we go into the challenges and kind of current issues, we want to highlight that many YouTube users, rather, today spend time engaging with our applications either on the mobile phone, desktop browser, or across many different types of living room devices like TVs, gaming consoles, set-top boxes, and streaming sticks. And while mobile accounts for majority of this usage, living room is rapidly growing for us as well. And both of these experiences account for more than about 88% of our user engagement today. So therefore, YouTube in connected cars today will rely heavily on these experiences that we already have. And the main choice today for automotive is mobile web. So we'll be recommending this almost exclusively to all the automotive partners right now for integrations. But the truth also is that mobile and living room experiences do not perfectly fit into the connected car context without some unique considerations that automotive brings to how users engage. And infotainment systems in vehicles must address several challenges to deliver seamless and enjoyable experiences while ensuring safety and functionality. So we'll highlight 3 of these challenges. First, let's begin with safety and driver distraction. Without a doubt, it's the most important feature as well as the most important pillar for us. We've been learning that there are many regulatory concerns we must comply with, particularly around driver distraction and how video content and music content need to have different types of rules around active watching while vehicles are in motion. And then secondly, technology integration as well as compatibility. Now, app development and technical dependencies require better understanding of the operating systems, SoCs, as well as application distribution options. So for example, we have some hardware dependencies in some cases which may take years to get adopted in this space still. Also knowing how to package and distribute our apps at scale takes more understanding of app stores and API integration frameworks across operating system. And then lastly, user interface and experiences. We've seen various form factors from head units in front seat to consoles in the rear seat. And it's quite different from our experiences on both mobile as well as living room. And while rear seat entertainment still best matches kind of small screen TVs, the head units can be much more complex and the integrations can be sometimes challenging. Speaking of which, we would like to also highlight a few issues that we've seen over the last couple of years and we've been kind of creatively navigating. First is, of course, speaking of different types of screens, non-standard aspect ratios. A 16:9 ratio is standard for YouTube, and of course with Shorts being integrated both for mobile as well as living room devices, what we're also kind of seeing is this adds to the viewable formats that we need to fit into the automotive space. And again, like we mentioned, rear seat entertainment format is still more like a tablet or a mini TV, which works out. But we could see a lot of various screens and types of screens in front seats, right? Wide screens, vertical screens, even round ones. And this sometimes breaks the user interface and requires a few workarounds as of right now. And then secondly, fragmented distribution and certification are still a challenge. As app-centric infotainment systems and connected cars are still emerging, we have seen many ways to distribute an application. We're looking into how we can solve this with centralized solutions for scale. For example, on Android-based systems, we're looking into providing a single source YouTube and YouTube Music APKs for all flavors of Android from AOSP, AAOS, and Google Automotive Services. And then lastly, there's, well, limited to no AV1 support right now in vehicles. And using advanced codecs like AV1 is really important to ensure the best YouTube watch experience for us. For connected cars, I think advanced codecs like AV1 can deliver a much higher quality of video playback with lower bandwidth consumption than the more common VP9 codec. But getting adoption for AV1 still requires everyone adopting a newer generation of SSCs, which can take a few years to take effect still. And before we go into the next section, we also want to say, over the last year, we've made a lot of good progress with automotive partners to learn how to best support YouTube experiences in this new vertical. And we're looking forward to continuing our partnerships with OEMs as well as integrators and bringing better and better solutions to our users. Now, in this final section, we want to talk about a couple of technologies, the adoption of which might really help provide better user experiences and richer kind of content in automotive, as well as we'll try to conclude with how you can better partner with YouTube if you want to deploy YouTube in your vehicles. So let's start with AV1. Well, improved video compression is important for delivering digital video files more quickly and with higher quality while using less bandwidth and storage. AV1 provides faster video startup, fewer rebuffs, and higher video quality. And in the living room, with all of our televisions and other connected devices, AV1 is practically ubiquitous across all new products that launched today. And it's about 30% more efficient than VP9, and again, about 60% more efficient or twice as much than H.264. In almost every device in the living room, AV1 is supported through hardware decodes at the SoC level today. Now, AV1 adoption in the auto industry is still very much at the beginning of the S-curve, and we will need to rely on the industry pushing for new hardware, new chipsets over the next few years to be able to enable richer experiences in automotive. The main benefit should be also obvious. Improved compression significantly reduces bandwidth consumption on the growing number of connected devices. And again, even the quality of video at lower bandwidth rates is better. And we also want to talk about Eclipsa. Look, vehicles are an optimal environment for spatial audio. YouTube's adoption of IMF ensures that creators will be able to provide new content very soon that can leverage this technology. And accessing such content within vehicles should be really an impressive experience for the listener, even more so than living room devices. Now, we quickly want to talk about how you automotive OEMs and partners can engage with YouTube if you're looking forward to deploying YouTube apps in your vehicles. Well, there's 3 broad steps in order to accomplish this. First, YouTube requires a trademark licensing agreement with all of the automotive partners directly, which enables us to license our marks as well as enable the deployment of the applications. So that's always step 1. And step 2 is certification, where we require automotive OEMs or their partners to really certify the critical user journeys that we want with our YouTube experience in automotive. And a good example of this is also our partnership with Google Automotive Services, where they themselves will take care of the certification process for you. And lastly, well, we also wanted to quickly touch upon branding, since we've seen this come up a bunch of times. And I think when you're planning for your launches, while you're looking at contracting as well as the certification process, usually getting creative assets approved with Google can take up to 4 to 6 weeks. So it's a good consideration to keep in mind when you're planning your launches. And this is, again, covered in the licensing agreement that we have with all auto OEMs. And with that, we'll conclude our presentation. We're looking forward to meeting all of you over the next 3 days. And if you have any questions, please run up to us. Thank you so much.
All right, good morning, everyone. In this session, we'll be talking about CAST for cars. So just a reminder, everything here is confidential, so shared under NDA and subject to change as well. So I'm David, and then Ying and Iwei, who is also on the CAST team, will be talking about some topics later as well. Cool, so in terms of the agenda, I'll be giving a quick overview of what CAST is in cars. I'll talk about the app ecosystem, and then Ying will come up to talk about some of the latest on integration, some of our new advanced features that we're rolling out, and then Iwei will close it out with some updates on certification. So what is CAST for cars? Basically, it's Google Cast like other form factors, but instead of now casting to a TV, you're able to cast to a car. And it's similar in many ways where you can use your phone to play and control content on the receiver device, in this case, the car. Just like for other form factors, Google Cast will also use the receiver's internet to stream content. In terms of some of the main benefits of Google Cast for cars, number one is that as a user, you don't need to install or sign into any apps on the car side in order to enjoy content. So this is particularly great for drivers and passengers who have everything already set up on their phones, and they can just play that content on the car. The second benefit is that Google Cast is cross-platform, which means that we support both Android and iOS phones, with over 5,000 apps supported through Cast. And then lastly, with Google Cast, you're able to control playback on the car itself. So things like play, pause, skip, and previous are all available on the car side as well. So one of the biggest benefits of Cast is the app ecosystem. We support 5,000 plus apps and growing. And these covers some of the top apps you're probably familiar with, like Prime Video and Hulu. But we also support top regional providers like Canal Plus and other content as well, like Facebook videos, Twitch, TikTok, and Google Slides. With these apps, with Cast, you're able to bring all of these apps the moment that you integrate with Cast. So we think that's one of the best benefits of Cast is the continuing growing app ecosystem. So with that, I'll pass it off to Ying.
Thank you, David. Hello, everyone. Hope you're having a great morning and hope you feel excited about what David is talking about the possibilities of Cast. So I will walk through some of the key steps to get a Cast working on your specific vehicle as a prototyping. So the first step is to unblock the full possibility of Cast, and it's 5,000 plus supported apps. You will need to have the Web1L1 keys provisioned on the head unit. So we do recommend to start the Web1 integration early, just to have the opportunity to unlock the full media library. And we have the Web1 team after this presentation to share more on that as well. The next part is you will need to provide a hotspot on the car head unit. And it's important to note that that hotspot needs to be operating on the same network as the rest of the head unit. So the phone can discover the car as a receiver, and then they can establish the connection between them. So after you have the hardware set up, you have the keys provisioned, then you will need to add the Cast for Cars project in the Android build, and also have the Cast Receiver APK pre-installed in the Android Automotive OS. The last step is to have the receiver certified. So you will need to authenticate the receiver, so we know it's a trusted device to cast to. For that, you can start with using a cast development key for prototyping, just because it's very simple and straightforward, and you can get it quickly going. But do note that while you move towards production ready, you will need to transition to the one provisioning process, which is official and more secure. Now, let's dive deeper into how the phone and the car connect to each other and discover each other. So right now, as the current primary mechanism, as I mentioned earlier, we require the car to provide a hotspot for the phone to connect to. And to make it simple, you can provide a QR code that contains the hotspot credentials, so the user can just scan the QR code from their phone and then get connected instantly. For this flow, we do require the car, the phone, and the shared Wi-Fi network to be all connected to the internet. So they will all need to have internet connectivity for the discovery and connection and content streaming to work. The other requirement, which I mentioned earlier, is that the Wi-Fi hotspot needs to be on the same network as the rest of the car system. And then we are also making this process more seamless for Android Automotive projected users. So if the phone is already connected to wireless Android Auto session, so Cast will directly use that established local network to cast for the phone to discover the car and then for them to communicate with each other. So this is a huge benefit just because it doesn't require any additional setup from the user, and also the user will not need to switch networks and things like that to make either of the feature works. So this makes Cast and AAP fully compatible without any further user actions. So for this flow, as you can see on the diagram here, both the car and the phone are still required to have internet connection themselves for the content to be able to stream. Looking further ahead, so we will be using Google's Nearby Connections framework to streamline the discovery process even more. So this future update will use Bluetooth to initiate the discovery. So this means the phone will no longer be required to the car's hotspot, and the car no longer needs to provide a hotspot for the phone to connect to. So this makes the initial connection faster and more intuitive than ever. Also, the same requirement still holds that the car and the phone still need to have internet connectivity just to enable the content to stream. I also want to share one more exciting feature is that we are enabling Cast to secondary display. This means when you open the Cast icon on the phone side, so you will actually be able to see more than one Cast target. So all of the additional screens you're enabling for casting needs to be run on the same Android user as the main display. And also at this point, we only limit one active Cast session at a time. So you can directly choose which screen you want to cast to, and it will directly land on that screen, but only one Cast session for that. So because this integration path heavily depends on the specific hardware and also the implementation for the secondary displays, so we do encourage you to connect with our team to discuss your unique requirements, and also we will be very happy to help you get through the process. With that, I will hand it over to Eve to talk about certification.
Okay, thank you. Okay, and about certification. All right. So to get optimal user experience while casting in vehicles, So there are several test set or test suite has to be performed and passed. So first, the compliance test suite, known as CTS, and WBTS, which is Wi-Fi test suite. These tests are we use to confirm that the playphone readiness. Okay, and the CAS test suite and radio test, manual test, which known as the critical user journey test. And these are the tests we use to verify the functionality of the cast. And the last, the performance test, which can evaluate the cast latency and the performance, and which the video is good enough and no glitch or audio lag. So these tasks are always intensive, and there are lots of efforts, and this is why we try to implement different tiers of the certification. There are 3 tiers. One that's for, light, and pre-certification. And this certification, each layer of certification actually includes the different set of the test. For certification will include the full set. So you have to test all the test suites we mentioned before. And then the light certification, you just have to do a subset of it. And the pre-certification, then you only have to do the essential test suite. For example, the CTS, which if you have modified your polyphone. So this certification actually address specifically the degree of modification on your polyphone. Okay. So, oh, sorry, too fast. I think that certification is, the most exciting part. Okay, so to try cast, please, you can following this step to get you ready for your vehicle or your playphone to actually integrate cast. And also, if you have any generic questions, you can talk to your point of contact at Google. And if you have any commercial questions, please talk to Michiel in the back. Could you raise your hand? Yeah. Yeah. Commercial things, talk to him. And so this is a super exciting feature we would like to bring up to all your vehicles. And then we will have office hour in these 3 days. So if you have any questions, please talk to us in the office hour, or if you meet us anywhere in the building or outside of the building. Okay. Then this is the patch. Thank you. Thank you very much.
Hi, everybody. I'm going to speak for Widevine today. I'm Fred Gillis-Caldwell. I'm the manager of the Widevine device team. And with me today is Kyle somewhere, maybe in the overflow room. And Juice couldn't make it, but they're also on my team. Here we go. Standard disclaimer, don't share everything, don't share anything. All right, so let me talk a little bit about the different integration paths you can get for Widevine. The conference is for gas mostly, so that's sort of the premium. If you're going to integrate with gas, then you want to work through the gas partner engineers. You'll register your device through APA. If you're doing Android AAOS, then you can work through their partner engineers. You can also register your device through the Widevine integration portal, but it's probably better to use APA. And finally, if you're doing a open source, Android open source project, then you don't get any, this is like flying coach. You don't get any partner engineers from the Android team. You have to work directly with Widevine, and we'll help you with that. You'll register your device through the Widevine portal. You're responsible for doing all your own testing and making sure all the integration works. And finally, the last choice is not Android at all. You can do a Linux integration. And then not only are you responsible for all the testing, you have to implement the glue layer between the Widevine CE/CDM package and whatever the application sits on top of. So if you're going through that route, you have a lot more work to do, or you have to have a third-party integrator to do that. We can give you some pointers. We can tell you some tests to run, but you don't get to use the Android GTS tests. All right, here are the design choices you have to make. First is provisioning. The traditional way of provisioning Widevine is using provisioning 2. We're trying to move people over to provisioning 4. There's a few exceptions. It depends on what type of device. For autos, there's a lot more exceptions than for mobile. Multi-display is something to consider, and whether or not the device is launched in China. Provisioning 4 does not work in China. The second thing that you need to think about is how displays are connected to the CPU. Traditionally, most of the devices we work with, if you're using HDMI, that means it's a user-accessible port, and so we require HDCP for that. On an automobile, if the cables are somehow buried inside the device, then we're willing to consider, for security and business reasons, that the HDMI cable is a local display, and you aren't required to use HDCP. However, you'll need to work with your SoC to make sure it's configured correctly and it's reported as a local display. If not, you might end up having it be viewed by the software as an external display with no HDCP, and the content provider will probably not give you premium content. And finally, there's an option for provisioning. Most devices are expected to provision in the factory, but we have made some exceptions for automobiles that are already in the field that you can provision key boxes over the air. This is a special case, so you need to talk to your Widevine partner engineer to figure out how to do that. You need to make sure that the software can handle that, and we need to audit how you're going to be transmitting the key boxes over the air. One design decision you have to make is whether you're going to be L1 or L3. L1 means that the keys, the content keys, and the buffers for content are going to be protected in protected by hardware. So usually, if you've got an ARM-based chip, then you're going to use Trust Zone. Intel has their own trusted execution environment. Those are all valid ways of doing it. Usually, there's a library called OEM Crypto that's provided by whoever your SoC vendor is. And then they're also responsible for making sure that secure buffers work for that platform. If you don't want to do that, you're probably not going to get high-definition content from the content providers. If you don't care about that, then L3 might be good enough, and then Widevine provides the L3 library. That just means it's software obfuscated. It's a little bit easier to break. It's not as secure, and so you're only going to get SD content. And finally, again, I'll talk about HDCP. For external displays, most content providers require L1 and HDCP in order to give the device high-end content. Let's talk a little bit about provisioning 4. And we can't do that without also talking about provisioning 2. So key boxes are provisioning 2. So that means Google provides you the key box. Each one is unique. It's the device maker's responsibility to make sure that every device gets its own unique key box. You have to protect it from leaks. It needs to be stored in secure storage somehow so that somebody can't just drive into a car wash and plug in a thumb drive and extract the key boxes. We're moving towards provisioning 4. We're starting to write that in the requirements. There's still exceptions for that. I already mentioned China, and we'll talk about multi-display next. Provisioning 4 is the device, the SoC chip generates its own keychain, a certificate chain that starts with the bootloader and moves forward. The technical term is DICE, if you're a chip maker, you've heard of that. What makes this more secure is, one, it's easier to provide new keys if there's a security update while keeping the root key the same. And second, the private keys for the key pairs stays on the device, so it's more difficult for that to leak. If you're going to use provisioning 4, this is probably something more for chip makers. You should make sure you're using the Widevine profile. This is going to be required for the next version. For this version, we just strongly recommend it. And basically, that means that the leaf cert of the chain is specifically for the Widevine TA. It should have the profile name of Widevine, it should have a component name of Widevine, and then it should have a mode that says whether you're running in debug or in production mode, and it should have a security version. We've recently updated the error codes that the provisioning server can report. So if you're trying to debug some issue, 400 means there's just a bug somewhere. 401 means you haven't registered that device yet. So if you're doing a bunch of testing and you're getting 401s, that means you have not yet uploaded or registered that particular device. A 403 either means that the device has been revoked, it's been detected that there's fraud going on, or more likely, you're trying to do cast provisioning. You've decided this device is going to be cast, but you haven't registered it in APA as a cast device. And so you just need to talk to your partner engineer. Somebody goes and edits a flag in the database, and then it should start working. A 500 is when you're trying to upload the BCC. You're doing provisioning 4. You're trying to register the device, and the system ID isn't recognized or isn't found. And so what that means is you've probably changed the name of the make or the model of the device. So you've registered an APA under one name, and now when you're uploading the BCCs, you've changed the values, and so you're getting some confusion on the server side. I'm going to go through these slides kind of fast. If you want to see more about how to register an APA, you can watch the mobile bootcamp slides. The important thing is question 4 here. You have to choose provisioning 4 or keybox. If you choose the wrong one, if you choose provisioning 4 and you're trying to download keyboxes, it won't let you. And if you choose keyboxes and you try to upload BCCs, it's not going to let you. So you have to get a human to change that for you if you've registered the device incorrectly. So that'll slow you down. So make sure if you know which one you're trying to do when you register the device. The other stuff is a little less important. Like if you get the wrong OEM crypto version, it's not that big a deal. That's the launch version, and the minor version nobody actually looks at. So. And then when you launch the product, make sure you register an APA that it's been launched, because in our database, we share information about which system IDs have been launched and which system IDs are still in testing. And if you aren't working with the content provider and the device is in testing, they probably won't give you production content. So once it's marked launched, then the partners will be able to see what that device is. Quick question, the 23, is that really how long I've been talking? Or did they not start the clock when I started? Am I way over time? I'm okay? I'm at 23. Oh, crap. OK, I will go very fast. All right, cast receiver. You need to make sure your OEM crypto does, in fact, support cast receivers. So cast receiver is true, has to be marked true. So run the OEM crypto unit test and look for cast receiver equals true. Otherwise, the test will pass just fine, but it won't work. And I'll go really fast through this part. If you're going to do multiple displays, content providers want a different system ID, or a different, sorry, not system ID, a different device ID for each display. And so if there's only one Widevine root of trust, there's different ways of doing that. The way we do it for Android 16 is we have a unique device ID that's not just unique to the device, but unique to the user and to the application. And so when different user logged in, they'll get a different ID. So for Android 16, you don't have to do anything special except, there we go, except set this RO product first API version. So make sure that's set to 16 and you'll be fine. If you're doing something else, then you might want to talk to us. Like if you're doing Linux, you need to talk to us about how you're going to do multi-display. All right, sorry, I ran over time. We're going to do question and answers next.
Hi, everyone. We're going to do a question and answer period now. So if there are any questions for any of the sessions this morning, please come back behind you. I'm right here. Come back to this mic, and you'll be able to ask questions to the audience. They have a mic that they'll pass around. So if you have any questions, please feel free to come back here, and we'll form a short queue for questions for the next 10 minutes. Who's brave enough to go first? Come on, this isn't a shy bunch. They're willing to answer questions. Oh, I think we have one. Yeah, please.
So hi, my question goes about cast for cars, especially the point about secondary displays. I've understood that cast for cars and secondary displays needs the same user as the driver, if that's correct. I was wondering how that relates to concurrent multi-user.
Yes. So currently, for the configurations we support right now, all of the displays have to run under the same Android user. It's separate from multiple user mounted displays. It's not supported right now.
Okay, thanks.
Yeah, thank you.
Thank you, Marco. Oh, please come back here if you have a question. Yes. I think it's a race. Who wants to go first? You can come first while you're here. Okay, Peter, go ahead. Okay.
So, hello, I have a question regarding the Gemini, because I really love using Gemini on my phone, but I have a question regarding the support of languages in the automotive. For example, we would be really happy if we could use Czech language, and Czech language is working in Gemini in phone, but it's be the same in the automotive?
Yeah, so we would bring Gemini to all the languages that GAS supports. But we'll start with English. There is a lot of quality testing that we have to do before we start rolling out to other languages. So that will happen starting towards the end of the year and going into next year.
Okay, thank you.
Hi, this is Tony from AMD. I want to know, out of the 300 apps you said you support now, how many usually, like percentage-wise, all support x86?
Yeah, so of the apps in GAS, almost all of them, I would say like 99% plus support x86 and ARM. We recently allowed app developers to publish only one SoC support at Google I/O. This is primarily for apps trying to build high-intensity experiences that have chips that can support them. But till date, like I would say 99% of apps support both SoCs.
And this is the strategy going forward. You always guys put in both.
We will not force developers to do both, but we encourage developers to do both so that they have the maximum reach across all cars.
Thank you.
Hi, my name's Mike. I'm actually with Harman International. So I had a question about Gemini specifically for the vehicle specialization or kind of the vehicle control. I like the direction that you're going in, but is this something that, and I guess I'm just curious how you're thinking about some of the challenges OEMs might have with the more traditional vehicle architecture with CAN messages and things like that, maybe not necessarily being accessible to the Android framework versus, or is this mainly intended for like a SDV architecture? I hope that makes sense, because there are certain features in the car that may not be readily accessible or that you can communicate with through a standard Android interface. Does that make sense?
Could you give some examples?
That's a great question. I don't have any specific examples, but like let's say like if you wanted to control Windows, HVAC is probably a little bit easier, but if there's certain I guess when I had worked with our teams and we had looked at trying to do vehicle control, that was one of the challenges that we had is certain things like for example, let's say, and I don't know if that falls into the category, but being able to control Windows, right? And I know that would have challenges if you close it on a person and you control it with voice control, but that may not be necessarily accessible by Android by default based on how a more traditional CAN architecture in the vehicle.
So without knowing the specifics, but I guess we would support anything that you control through VHEL. Then there could be custom intents as well that could be supported. So anything that could be supported through IVI, I guess should be able to be supported through what we are building. But I'm happy to kind of go into more details with our partner engineering team and our engineering team to figure out exactly which use cases you're talking about and whether those would be supported or not.
Okay, great. Will you guys have a list overall of what can and cannot be controlled or what's going to be on the roadmap of specific functions?
So the way we are thinking about it is it would be more of a platform and tool, right? And then OEMs can fit into it whatever functionality they want to control through WISE. But again, we can talk about the categories or with specific, do they have to be standard intents or custom intents and so on. We can definitely follow up on it.
Okay, thank you.
Thanks, Mike. Hi, so I'm Robert from VW. Question regarding apps. So I'm very excited to hear that you plan to extend or allow apps to also show content on the cluster display, which is unfortunately quite delicate regarding regulatory requirements. So could you elaborate a little more how you incorporate those regulatory requirements that apps kind of more or less automatically have to comply with if they show content on the cluster display?
Yeah, cluster display typically is going to be restricted to navigation apps and specifically to draw navigation maps along with some high-level information. They are also very templated when we make it available for developers to feed that information to. We do have some certifications planned for OEMs to also make sure that the right templates are surfaced, so it's like bi-directional. But the way we regulate which categories of apps can use cluster and what interfaces they have through the car app library is how we manage control of both quality and safety for content on the cluster display.
Okay, so just that I got it right. So as the OEM, we have to ensure that the templates are displayed correctly, and as an app developer, I have to make sure and I have to prove that I used the template correctly.
Correct. Yeah.
Okay, thank you.
Hi, Marius from P3. I have two questions. One regarding CAST and certification. Is going to be CAS part of the XTL certification, or is going to be something separate? And do you plan to do this somehow also very formal, like a 3PL certifying CAST, or you'll still want to do it internally?
Yeah, for CAST, part of the test will be included in the gas certification. It's in gas certification already, right? So if you are not a gas partner, you have to run it separately. And we are not planning to have a third party or a vendor testing program for that. But we can always talk more about the details. If you really need that, we can talk about it.
Okay, perfect. Second question regarding the Pixel tablet. The Pixel tablet, as is seen now, is more for ready-to-build images, gas, non-gas. And there is already a one page allowing us to compile and put our own version flavors of Android. And that one is not really maintained so much. Do you still plan to maintain in the future, or you want to sundown that feature?
If I understood the question correctly, there is one around building builds for Pixel tablets.
Yes, exactly.
From like open source. Maybe we need to show more love on it, but we should be releasing, we are releasing all the builds that we release for open source that can be built into AOSP. But we did connect a bit offline as well. There is definitely some documentation improvements that we can make to call out which releases are out there. So that's feedback taken, and we'll follow up on that.
Okay, thank you.
Hi, I'm from ChipSync India. So my question is like for white wine, what is the L3 resolution is supported?
It's kind of a business decision by the content provider, but most content providers usually just give SD content, so 450p or something like that.
Okay. Yeah. And for this, for the cast, Netflix is supported, or?
No, Netflix is not supported. It's the main exception.
Okay, thanks.
Hello, this is Webo. I have a question regarding cast. When we cast in the head unit, so would it occupy the full screen, or can we adjust the size of display?
Yeah, so by default, it will occupy full screen. It will be in like immersive mode, so like users can better enjoy the content.
Yeah, so as the display area of the head unit and the cell phone is normally different. So would it cause something black or other, around the display area?
Yeah, I want to clarify one thing. So cast in cars, like the content directly comes from the app server. So for example, if you are casting Amazon Prime Video, the content directly comes from Prime Video server, and we will pass the configuration for the car display to the app server, so they can choose which content to stream, and also the content will fit perfectly on the car screen. So it's not like exactly like you are mirroring your phone screen to the car screen. It's different.
Okay, thank you.
One more question, and then we'll break for lunch, but we'll have a specific announcement before that, so let's finish with this last question.
Hey, Shuai Faraday Future. Question for Gemini. How much of the in-car experience is connected to the mobile and the rest of the Gemini experience? Say, if I make a note, I drive, I take a note in the car, how do I consume that? Can I already have access of these out of the other surfaces?
So is the question...
Start off in the car, finish in the on the web, or on the mobile app. Is that already available?
Yes. So for something where you are taking a note or you are adding an event to your calendar, things like that, you would be able to access it across devices.
Cool. Thank you.
Hey, some online questions. Thank you, audience, for a lot of questions from online forum as well. We'll not be able to get all the questions from the online. We'll respond in line and post it on the site. I think I'll pick one question from the online forum, and this, I believe, is targeted towards Thorsten. The question goes, do you have a vision for the unified phone head unit experiences? Example, seamless continuation of the phone in the car.
Can you just repeat the question one more time? Is it a seamless experience between phone and car?
Yes. The question goes like, do you have a vision for the unified phone head unit experience? Example, seamless continuation of the phone in the car.
Got it. Okay, I mean, today, of course, we have Android Auto and Cast, right? But we do have other plans that we're not ready to talk about quite yet. But we're definitely thinking about a more seamless integration, yes.
Okay. Thank you for the Q&A session. I'm going to hand it over to Chris here in a little bit, but thanks everyone for on the panel above at the podium. Thank you.
The what?
Yeah. Except one, except Raj.
so welcome to this session, and I will talk a bit about Android Automotive OS platform development on Google Cloud. I hope you enjoyed lunch, and yeah, thanks for being here. Then let's directly move on with the content. So all of this is confidential and only shared under NDA, so please don't publish, and also please don't take any pictures of the contents. My name is Florian Hauptner. I'm Industry Architect Lead for Automotive at EMEA, and I will present together with my colleague Mike, who is with me today as well.
Yep, everyone, Mike here, engineer, Google Cloud.
Yeah. Good. When we look into automotive software development in general, then the whole market is relatively fragmented. So looking into the SDV space, there are a lot of different frameworks available. There are a lot of different technologies available. And in general, what we observe is that the whole process is relatively hardware-oriented. So most of the time, hardware is in the lead in this process. And also most of the time, developers have an actual test bench where they then test often on their desks, or where they often test afterwards. In general, what is complicated is on the one side test bench availability. So meaning often not all developers have test benches available, but only a few developers might have them. In addition to test bench availability, the other issue is basically that test benches are often in different configurations, meaning, for example, for one specific test bench, you might have a specific version basically put onto it, and you might have certain peripherals connected to it. However, these configurations basically get relatively complicated because you have so many permutations of devices that you might connect. And at the end, it's also, I would say, a thing of mindset. Because when basically observing or talking to the different OEMs and tier ones, I often have the impression that you only believe on basically when it's working in the car, you believe it's working. However, in many other situations, basically whenever you test virtual, it's not always the case that management believes that the features are actually working. So I have the feeling that current mindset is still we need to see it in the car to believe that it's working. Going forward, what we envision is we envision this development cycle to be software-led. So meaning what we want to embrace is virtual, and it should be virtual first. Because otherwise, it's relatively difficult to scale, and it's also very difficult to iterate, and very difficult basically for all developers to have test benches available in a virtual setup, and to test often and test early. And I think it's a relatively long process we need to go through. And this process is about building confidence in virtual and showing to management and leadership that whenever it's working virtual, it will also work in the vehicle later. What we believe in is that platforms enabling efficient software development shouldn't be differentiating. So we've been talking to various partners in the past, and many of these partners had similar challenges. For example, how do I optimize build times? How do I do efficient caching? How do I, for example, set up Cuttlefish, Cloud Android, basically on cloud? And all these challenges we wanted to solve basically once as part of a reference platform, despite basically talking to different customers or different partners at different times. And this is why we engaged together with Android and also Accenture to provide such a reference implementation for a cloud-based development platform. What we also believe in is that the product itself should be differentiating. So meaning we would like to see that less and less developers are required to actually maintain a development platform, and that more and more developers can actually then build the respective features, and that most of the time and effort is spent on differentiating features. Accenture is one of the partners that we are collaborating on that. So we released together with Accenture the so-called Horizon open source project and development platform. And Accenture has also contributed a lot of the code and a lot of the technology that they've been internally working on as part of this reference platform. A lot of this is open source, and Accenture, in this case, is from a cloud side our preferred partner in this context. However, you can also use it basically on your own if you want to. However, we believe that the fastest way to get to value is doing it together.
Yeah, as Troy mentioned, with Horizon, we essentially aim to introduce an open standard. Open because we want developers and partners to see what's inside and how to customize, but also a standard to really increase adoption and provide some type of reusability here in this space. What's worth mentioning, I think, is that there are partially open source components, so we think of it as open source first within the reference, but then there are also partially commercial products. So for areas where where commercial products are best in class, we would integrate those within Horizon. And on top of that, because within Google Cloud, we also have lots of components and solutions that provide value there. We also have components which are primarily available on Google Cloud only, so native GCP products, such as cloud workstations that you'll hear about more. This is essentially the aim of Horizon and part of the code build test pipeline that we envision. Also, it's important to note that Horizon is pursued in two streams. Where we are at the moment is stream 1, which focuses on Android tooling. And then there is, I call it rest of SDV. So this is enabling also mixed criticality systems, going potentially beyond Android, also including some of the AAOS SDV components and going beyond there. So in the first release, the focus was really on the Android tooling, so providing this reference for Android automotive workloads development in the cloud, and more to come in stream 2 that we're closely looking at now. Also, we're here looking to work with partners to really expand the scope, stay on the open standard path, but onboard partners here to make this even broader. And here a quick call out that on day 3, there are a couple of sessions also on SDV and our breakouts where we go into more detail in this.
Then looking into the value proposition itself. So these are some examples of value proposition that we see when moving towards a software-led development process. Also, some of them basically being measured on the Horizon developer platform. There's a few ones that I would like to call out. One of them is the build time reduction. I think this is a typical challenge to basically get the build times of Android platform builds down. And on the other side also to make these builds reliable. And this is something where we recently had a hackathon a few weeks ago. And one of our partners was basically setting up such setup on their own code base. So they were using one technology, there's an Android technology called Android Build File System. You will hear about it later as well. And what we achieved there is basically, it was without optimizations on the code base itself, we saw a 97% reduction in build times. And on the same time, we basically saw high build reliability because it is basically built in a way that build times are reduced, builds are very efficiently, and also that builds are reliable and hidden dependencies and so on can be identified. What we have there as well is basically, as part of Horizon, the open source release, we have already approaches for incremental builds with disk swapping, so meaning using persistent disks for build execution itself. Another thing to call out is cycle times in general. So due to lower build times, due to faster onboarding, and so on, we see reductions of cycle times of up to 30%. So meaning you can release more often, you can build more often, and you can also test more often in this virtual setup. In addition, there is one more aspect, which is maintenance. So in many cases, this tooling is currently maintained internally at different partners. And we also see benefits of just maintaining it once in an open source setup versus basically each party maintaining and optimizing it on their own. With that, I will hand over to Mike for the code part.
Yeah, let's start with the code part now. So we'll quickly go through each of these steps of the Horizon platform and go into some more detail there. Let's start with the code part. So here, our aim is to improve the developer's flow state. So essentially allowing developers to seamlessly onboard to the development and getting started quickly, and also be cost effective and efficient throughout the way. Today, you see usually local machines, local Android Studio environments, IDEs being used. This is I'd say the norm today. But imagine if you could simply get a cloud-based dev environment ready in seconds, which is already tightly integrated with the rest of the tool chain. So where developers can get onboarded, get the latest packages, can start to deploy things straight away. And now from a networking perspective, also pretty much in the same internal network where all the rest of emulators, test devices are, etc. That's essentially a cloud workstation. More on that as well right after this talk. You can access it via web browser or SSH, also from your local instances. But what you essentially do is you configure a container image, you configure what power you give to that machine, and you then share it with your developers. It's important to note that usually in automotive, we don't only have internal developers in small groups. It can grow quite quickly, and it can become these projects can become quite complex. So this is where even these workstations can be shared with developers from your partner organizations that you work with, which is where the security part comes into play, where I'd like to focus on a bit more. Because from a security perspective, you can have admins, teams responsible for centrally configuring how such a workstation looks like. Then you now have sameness across all developers, that they use the same tools, that they're on the latest versions, all the security patches applied whenever a new image gets started. And all you have to do is you have to share web access to this IDE, and developers can get up and running. Together with other Google Cloud solutions like Chrome Enterprise, for example, you can even prevent download of artifacts because everything is sort of in a dedicated browser space. So it makes things way more secure. And on top of that, Cloud Workstations also integrate with Gemini Code Assist, and the enterprise version of it might be of most interest because here you can connect it to your own code base and then thus have very contextually relevant code suggestions, highly relevant to your scope of project of what you've done in the past. Furthermore, within the code part, and as mentioned, some components are commercial offerings, and to ensure that there is enterprise suitability. And for that, for example, for multi-site Gerrit deployments, globally accessible environments for Gerrit, for example, we are partnering with Gerrit Forge to provide a Gerrit code review as a service. That's available on the Google Cloud Marketplace, so you can straight away leverage that and have a fully enterprise-grade Gerrit service within the Horizon platform.
And now looking into the area of build execution and build time optimization. So the build setup that we have as part of the open source project is Kubernetes-based. So there will be a Kubernetes cluster that will be spun up in the own tenant. And in this Kubernetes cluster, you see different node pools. Some of the node pools are for general applications, like, for example, different tools that we deploy there. And then we have additional node pools with nodes that are larger machines. And these nodes, they will be used for build execution. We have there implemented things like automated scaling. So whenever, for example, builds are executed, there are build nodes present, and each build is executed on a dedicated node. However, whenever there are no builds executed, it just scales down to 0 so that you have also the cost optimized. In addition, what you see here is warmed workspaces. So these will be mounted at runtime or build execution time. And this is the basis for incremental builds in this setup. Going forward, the mechanism will be Android build file system. However, in the current implementation that we have, it's these warmed workspaces that you could use. In general, looking into the overall build setup or the sequence itself, we have containerized build environments, so meaning everything is just executed and packaged as a container. That means whenever you need to reproduce something, build something again, maybe even an older setup, you can just use the respective container for executing these builds. In addition, there are several build targets that are already supported. There we support, for example, Raspberry Pi, we have Pixel tablet, build targets available, then for sure there are virtual targets like Cuttlefish and AVD. The build timings and optimizations, this is dashboards that we have there, plus the mechanisms that are integrated and implemented in the background that make use of these workspaces. And in general, the pipelines are built relatively modular and flexible. So you don't need to use all of this, but you can also just take these parts that are applicable to you or these parts that you want to try out or test. And this is also true beyond build execution for the rest of the platform. It was built with the intent that for a lot of the things you might already have solutions in place, so you can just take these parts where you might not have solutions yet, or where this platform might provide easier, more scalable, or better solutions. Then there is one technology that is, from my perspective, particularly interesting, which is the Android build file system. And with Android build file system, you can sync Android in seconds and build it in minutes. This is a technology that is provided by the Android team, and that is a commercial product that is currently in early access. There is a dedicated session at 2 p.m. today that will be focusing on Android build file system and on the specifics here. What I would like to point out is that with Android build file system, it is a file system optimized for Android builds. And what you get is not only fast Android builds, but you also get reliable Android builds, meaning you typically would not need to execute full builds again.
After build comes test. I hope we all agree. That was obviously a very important element here. As initially mentioned, the development cycle is quite hardware-led today. And from all these different sort of testing areas, we focus with Horizon on the virtual hardware in the loop. So here also shifting left and enabling earlier, more comprehensive testing, for example, for the Android infotainment ECU. This is our focus area, as we obviously want to come close to the hardware benches, to hardware environments, to allow you for reliable testing in the cloud. What you get as benefits is, as already stated, faster development cycles, earlier bug fixes, improved test scalability, and also higher quality builds. This allows for system integration and validation testing, the CTS testing as well, and others that you can straight away embed there. What do we have as an essential cornerstone within this virtual platform? It's AAOS Cuttlefish. This, especially crafted for virtualization and therefore for cloud, allows us to have a virtual device that's made for high fidelity device emulation. Using standard VirtIO, it means high performance on the host machine, capable to simulate a range of different Android devices. So that means that we use this to spin up specific devices, virtual test environments on a cloud machine, like actual hardware. You can see here a product scenario where on the left side you have a Type 1 hypervisor, host machine, and AAOS. And you can see how the emulated environment on Google Cloud looks like with the GCE, the Google Compute Engine hypervisor, then a KVM-enabled Compute Engine instance as per your needs with the right size, etc., and the Cuttlefish VMM running on top of it. Ultimately, this allows you for realistic virtual test benches in the cloud. Also, here is an illustration of an automated test system for an AAOS build, which has 3 core pipeline jobs. It starts with the Cuttlefish instance template creation. So that's the foundation. It creates a reusable virtual machine template in Google Cloud. It comes with pre-configurations and all the required dependencies, etc., that need to be on that machine, network configurations, etc., that need to be in place. So that's the first step that you can kick off with a pre-built pipeline within Horizon. Then it continues with a launcher pipeline. So that takes the CVD image as an output from the AAOS build process and deploys that onto that fresh VM instance from the previous template. So that's a second step. And lastly, you have for example, the CTS execution. So you have, once the device is up and running, the ability to execute the pipeline and execute a test suite against it, such as CTS. It means ultimately that you have, with Horizon, a fully automated end-to-end process for building and validating Android Automotive OS images here. Now, how do we access these various targets, virtual, but also physical labs potentially? Here's where MTK Connect comes into play. Also, fully part of Horizon, it allows for a seamless interaction with virtual targets and physical hardware, including but not limited to cuttlefish devices, pixel devices, and also access to CLI, such as ADB, Logcat output, and SSH. What's important here is that this is easily accessible via web interface, so simply, again, shareable with a group of developers here, and also more details in the deep dive session later today. Also, you can check out the MTK Connect demo at the Accenture booth right next door in the demo area if you'd like to see hands-on how this looks like.
And maybe adding one note on the abbreviation MTK Connect. So it has nothing to do with MediaTek. So just for clarifying, because we got this question already multiple times, maybe we need to discuss with Accenture at some point in time if we should rename it to something different, because there was at least some ambiguity involved. Yeah. Then how to get started. So what we have available here is a few QR codes that you could use in order to access these resources. The first thing you could look into is if the Horizon development platform itself is interesting for you. Then we have here the link to the repository itself. So it's published on GitHub. We will also have at 2:20 p.m. A few additional technical details on the Horizon development platform. Then for the Android build file system, this is something where we have an intake form here for people and partners that are interested in early access for Android build file system. We need to work on together with the Android team to then prioritize these requests because we already received a bunch of requests. However, if you're interested, submit this form or directly contact us. Then in addition, cloud workstations is something that Mike already presented. And this is something where you can also give it a try. So this is a link to a repository where we have the different configurations available. And as the next session, you will also hear from Femi, Sam, and Tait more details about cloud workstation. And in general, Axion is our ARM silicon that was introduced in 2024. And if we look into the different offerings that we have, we recently introduced, for example, for Intel and AMD machines for x86, we introduced bare metal offerings. And our goal is also to provide bare metal offerings on all platforms in the portfolio, including Axion. We will have, in addition, some breakouts for Android software, Android platform development, plus also, I would say, automotive software development beyond Android in the next 2 days. And thanks a lot for listening.
Hello, everyone. Okay, good. So my colleagues and I, Sam Lean and Tait Holmes, will take the next 20 minutes to walk you through the problem, which I'm sure you're all familiar with, the cloud-based industry solution we created. And then we'll walk you through a customer that has actually applied this and what they say about it. And then Sam will come on and talk to you about what the day in the life of your developers would look like. And Tait will end with walking you through how you set this up yourself. So how does what we're talking about now connect to what my colleagues Florian and Mike just talked about? essentially, the reference architecture is based off of the cloud-based industry solution we created. So without much ado, we'll start. By show of hands, how many folks here actively work on Android platform? OK, great. We're in the right room. OK, so I think I've gone through this. These are the folks I'll be presenting to you in that particular order. So yes. So you heard from Florian that on-prem Android platform development is challenging. That's what we heard from our customers as well. And so the slide in front of you aggregates the feedback we got from our customers. Now, given the fact that quite a number of people in here work on Android platform development, do these, by show of hands, how many of you do these problems resonate with? OK, that's great. Again, we're in the right room. OK, good. So we got all these problems from our customers, and as good product folks will do, we said, OK, how do we solve this problem? And then this image you saw earlier on, which is the reference architecture for Horizon, we're leveraging it here because, again, it's a cloud-based industry solution that we created from this. And that cloud-based industry solution was set up to address the challenges in the preceding slide. OK, like I said before, problem, solution. Now, where has it been applied? Who has applied it? And what do they have to say after applying it? So the slide in front of you shows you, answers all those questions. To the left, you see the improvement that our customers saw in reduction in onboarding time. Our customer used to have a multi-day onboarding for their new hires or new developers. That went down to 15 minutes, which was huge for them. Our customer used to have long build and sync times for Android, and that went down tremendously by 99%. And so the customer was happy enough about these improvements to sit down with us and have a conversation with us about it. And what you see to the right is a quote from the customer summing up how much improvement they've seen and how this has helped them go to market faster. Their time to market, when the solution we created was applied to their SDV project, their time to market was improved by over a year. So the chief software officer for our customer, Ampere Renault, was happy enough to tell us, hey, Google rocks when it comes to this. With AI, my developers are more productive. And the fact that you can instantiate a workstation and you no longer have long build and sync times is fantastic. I'll give you a moment to take the quote in, see if you want to read it. We have to pause when you have good things customers say about you. Now, on to the next slide. Again, voice of the customer. This is the voice of the platform admin or the product owner for CI virtualization for Ampere Renault. I will give you a moment to take this in, then I will gladly hype some of the key things that were said here. OK, so great mention of Gemini Code Assist, how it's been enabled for the majority of their developers. Great mention of the fact that with our AI assistants, they've enabled RAG. That has given them great context. They've got great code generation, and it's working awesome for them. They give an example. And lastly, the platform admin says, this is a game changer. I'll let that sink in for a second. This is a game changer. And so just so you know, the customer reference here, Ampere Renault, are here with us today. They have set up in one of the rooms for the demo. They're right in the middle. So if you want to interact with them and talk to them about how they've implemented this and how it's working for them, you can hear this directly from them. So by any chance, are the Ampere Renault folks in the room? If so, can you please stand? OK, that's great. So please go see this nice folks next to their demo, ask them questions, get to know how in real time this is working for them, because they've deployed this. And so we'd like you to talk to them so you can see how it applies to you. If after talking to them, you want to proceed, I'm sure you can, I believe your partner engineering folks are available to walk you through the next steps. Also, like Florian mentioned, you can talk to Horizon, you can leverage the Horizon open source project by talking to that team, and you can get to see how this applies to you. Okay, without much ado, I will transition to my colleague Sam. He will walk you through a day in the life of your developer when you apply the solution to your organization. Thank you very much, everyone.
Thanks, Femi. So let's talk about what the solution look like. And there are actually two parts of it. The first part of it is for developer, right? And second part is how you build that infrastructure to get all the magic work out for you. Right? I will walk through the developer workflow first, and later Tahi will talk to you about how you build those infrastructure. So the first is for developer. As a developer, when I need to start to change one line code, what do you do today? Typically, you need to sing for 20 minutes, and you need to build your first build, taking an hour or two-ish, right? And if you are using the Android Studio for plain phone, it probably take you another hour to sync, right? And with this solution, we will actually enable developer to do all the work on the Chrome browser. Of course, you can pick other browser as well, right? But we recommend Chrome browser for a particular reason. So the workflow look like is developer open the Chrome browser, and they can immediately create a cloud workstation on cloud. And with this cloud workstation, there are actually two parts to it. The first part to it is there's the container image, contain all the development tool and IDE you need. Right, that's the first part. Then second part of it is there's a persistent disk with all the source code checkout and all the preview ready for you. So you literally can just get started code within the few minutes. Right? And in order for this to work, Tahi will walk you through. You can set up for multiple branch, multiple device, and developer will be able to use it immediately without going through a few hour wait time. Right? And this is the part that will significantly reduce your time to code. Okay, let's look at the few detail, right? The first one is we don't pick IDE. I know everybody have their preference IDE, right? Show me your hands if you are building APK. Your company is building APK. Okay, a lot of companies building APK, right? And obviously, when you build an Android app, the choice for a professional developer typically will be Android Studio. And obviously, you can set up the Android Studio with Cloud Workstation to work for you. Then anyone building for device image, okay? There are quite a lot of people building device image. And everyone building device image, you know, is much more challenge because there is no purpose-built IDE for you. But luckily, the Android Studio team, they actually started to build Android Studio for plain phone a few years back and make it much useful for device development, especially for those like soon build system integration. That's the game changer, right? And you can using all the benefit for the modern IDE and to be able to make you code more productively. There's one more thing that when you work with Android Studio for plain phone, because we do hear people talk about Android code base is huge. There are like a few hundred gig of a code base. And if you need IDE to index for you, that's going to take you another hour or two, right? With this Cloud Workstation, you can also pre-bake it. And so your developer doesn't need to wait for that. They can immediately jump to the code as well, right? And of course, within the car, it's not just about Android device and APK. There are also additional software you need to build for SDV, right? A lot of people using the Code OS for SDV as well. You can also set it up with the Cloud Workstation, right? And for example, the customer you're going to see in the demo, they are actually using the Code OS to do the Rust or other software development. They also get all the benefit Cloud Workstation have, okay? Then that's just not about the IDE, right? Because if you just using IDE, of course, you will be more productive. But there are also the magic we want to bring in. And this is the part I'm really excited about it, is about the Gemini Code Assist, right? Anyone in your company start to try out the AI Code Assist, doesn't need to be Gemini. You can try other things as well, right? We do hear a lot of developers start to try out. And most common thing we hear is, it's good, but it's not great yet. And we all know about that. right? And we do have like a hypothesis that over years, you will continue to improve. For example, you compare last year to this year, it's actually a step function, right? But not just about that, because if you think about the language model, it can actually be a reasonable good junior engineer or the new grad. But it doesn't have all those domain knowledge you have, right? We already know you can build a reasonable web app, right? But it's probably not as good to building Android app. Don't even talk about device, right? And this is the part we want to start to bring in and say, how can we actually put Gemini Code Assist into your workflow? And of course, pre-integrate with Cloud Workstation so you can get all the benefit out of it, right? Okay, I'm going to walk you through 3 different use cases, which is typically the developer will work on the IVI side, right? And to show you why this is beneficial to you. Right. The first one is about can you be faster to code, right? And this is the part I already talked about. Say you're going to take like a 1 or 2 hour lead time before you changing any one-line code, right? For example, last year I was on the traveling on the train, and all of a sudden I need to do a demo, say how to do this Cloud Workstation. I can literally jump onto my notebook with my mobile connection. I can actually, with one click, I can create a Cloud Workstation I need and also start to debug. Right? And this is pretty much the thing, say, your developer can actually using it today if we set it up. And it's just not just about that, right? So anyone is excited about fixing a bug today? As a developer, you're all excited about implement the feature, but unfortunately, day-to-day, you do need to fix the bug, right? For example, there's a use case I would say I need to fix the CTS issue. And this CTS, you're going to block my next release, which is really, really urgent, right? Then what you need to do today is you need to open the test code file, which is, for example, this is the example, they have a 2,000 line of code, right? And this is written in 2015. Even if I write that, right, I forget about it, right? And that's a typical workflow every developer need to go through to burn down a bug, right? But with Gemini Code Assistant, I can literally tell Gemini, say, this is the source code. This is state trace. Please tell me what is the fixed option. And we actually run it through. Most of the time, it's not great, but sometimes you get lucky, right? The fixed option for this particular case is pretty good already. At least better than myself, right? And this is actually shorten the time, right? But not just about that, because we do care about quality, right? And you look at a fix, it can be say, oh, this is just a workaround, right? So I can even follow up to ask the Gemini, say, can you please show me the trade-off between these two the option, right? And tell me what is the best option. And this actually literally help me to be able to do the similar job a domain expert can do, right? Without me going through a few hours of reading the code, right? And this is the part can all within your IDE. And we believe this is a game changer, at least for me, right? Okay, next one. When is your last time you can implement anything from scratch end to end? Just like say, oh, go to write a web app, right? A lot of people, especially for people getting into the industry or they are doing the pet project or toy project, right? That is the use case. But as a professional developer, that is not your day-to-day life. When you go to do a feature implement, you most likely need to work on the existing code base. And you'll be lucky that the existing code base is written by you, but most of the time it's written by other company or other team, right? So this is the part difficult for developers. Say, I need to spend quite a lot of time to understand my existing code base and see how I can extend to it, right? For example, let's talk about 2 use cases. The first one is, anyone hear about this biometric prompt API? Okay. If you don't know, you just go to search or read an API document, right? But right now with Gemini, within your ID, you can say, please tell me how to use this API, even give you a code snippet. So you can start to integrate into your code base or doing the feature development you need, right? And the second part of it is I say, right, most of the time, the code is written by your colleague or someone else, right? In order for you to extend it, you need to be able to understand it. Right? And you probably spend a lot of time reading through, right? Gemini can actually give you a document, tell you what the code about if there's no comment on the doc, right? And this is also going to significantly reduce your time to code and even speed up your development workflow, right? And we are pretty excited about those improvement on productivity, right? We know it's still early, but we see the potential. That's why we want you guys to join a club and work with us. With that, I will hand over to my colleague. He will show you how you build this infrastructure.
Thank you, Sam. And now we are really excited and want to start with Android Studio profiting from Gemini Code Assist. So, and of course, we want to do this in the cloud, right? So our product for developing in the cloud is Cloud Workstations. And we heard our customers asking for Android Studio for platform. And while we offer you a couple of managed images for Cloud Workstations, we also provide you a way how you can create and use your own custom image. So for this, we have open sourced this repository where you find a couple of examples with Docker files, related files here that help you to build your custom image from scratch that can be tailored for your organization. And specifically, you find here an example where you can build an Ubuntu-based image here with Android Studio for platform. So have a look there. And of course, in an enterprise setup, at least, we need to really automate this. So let's start with a CI process. We need to watch a repository where we put in this code, and we trigger a build whenever there's a change. So far, so good, but this is not sufficient, right? Because we have a dependency here on a base layer, which is, for example, Ubuntu, and we really need and want to profit from all the updates and security fixes. So on a daily, nightly basis, we need to configure here something like Cloud Scheduler to trigger here our CI process. It will build a new image, container image. It would upload this to Artifact Registry, and this is where Cloud Workstation can then pull from. On the right-hand side, you see that Cloud Workstation instances use persistent disks for their home directory. So source code such as AOSP can live there. And we see also a disk snapshot. And in the context of AOSP, we have heard this is, of course, a pre-built, right? So we want to create Cloud Workstation images with a PD, a persistent disk here based on the pre-built, so that we profit here from accelerated builds. And whenever a developer starts their Cloud Workstations, we can make sure this way that they have the latest up-to-date image and profiting from all the fixes and updates. So in the previous slide, we already have seen there are three important resource types when it comes to Cloud Workstations. The one is the cluster, the other one is the config. And think about the Cloud Workstation config as a template for your Cloud Workstation instances. So it defines things like the machine type, but then also the image that is used coming with the operating system, and then also the different tools, and also the persistent disk for the home directory. And here we've seen we can use snapshots. And those snapshots can be then created through a different continuous integration process. They can be created manually by an admin. They can also be created by a process here on an automated way. And let's have a look how this relates to the concept of AOSP and platform development. So when we think about pre-built disks and we would want to profit here from reduced build time, we need to take into consideration a couple of factors. The one is the Git branch. Which Git branch shall be watched and used to create a build? And in your company, you may have different branches here depending on different features or brands and the like. Then also we have the launch targets, and that can relate, for example, to the architecture. So all of those combinations and the product of these factors, they actually define how many Cloud Workstation configs we would want to provide our developers to choose from. And here we really ask the question like how to navigate all of this in Google Cloud. So what I show you here is an approach how we can map the different combinations to distinct Cloud Workstation configurations. So what we do here is that we create Cloud Workstation configs here for the different combinations. And note that leaving the concept of instance pooling aside, there are no instance costs from running instances, right? Given even the multitude of configs that we have here in place. But it permits developers to choose their exact combination to then instantiate and use a workstation instance from on demand. So of course, such automation needs automation from the scratch. And thanks to infra as code, this can be done then also at scale. And it permits tailored and also adjustable deployments through the use of variables that you can use here to specify the Git branches, the targets, and the like. So we have seen for the automation that we want to use CI at least. We have an open source repository here, the CI/CD Foundation, and this is also leveraged in this context. It focuses on secure, generic CI/CD for containerized workload in Google Cloud. And it targets runtimes such as Cloud Run, GKE, and in our work, in our context, the runtime is Cloud Workstations. So let's have a look how the entire architecture looks like when we do such provisioning. You can use this diagram as a reference. For example, if you want to substitute maybe the one or other solution, and yeah, it indicates all the different dependencies, roles required, IAM permissions granted, and the workflows, both from the infra as code side, but also from the users. So now that we can use Android Studio with Gemini Code Assist in the cloud using Cloud Workstations, questions is, what's next? Yeah, we have seen this way we can support the use of pre-built disks. In the context of the Horizon SDV open source initiative, we aim at integrating this approach also for seamless tailored deployment. So that's one thing. And then also, and we will learn and hear about that, we want to integrate ABFS into Cloud Workstations. So to benefit here from ABFS accelerated builds too. And in general, we aim at also providing all of our results here as part of the Horizon SDV repository. So watch this space, follow this repository. With this, we'd like to thank you for your attention. And please visit the various demos and office hours that my co-presenters and myself also provide to you. We are happy to hear from you, and we can then deep dive into the various topics in more detail in case you want to do a deployment and the like. So thank you very much, and enjoy the rest of the bootcamp.
Good afternoon, everyone. Sorry, we'll wait for some people to clear out. Good afternoon. Hopefully the lunch isn't hitting you too hard for that post-lunch nap time. Google's known for their nap pods. I'm here to talk to you about the Android Build File System, or ABFS. You've heard it mentioned in the previous couple of talks. And let's dive into the technical details of it. A reminder that everything we talk about is under NDA. And my name is Eric Sanders. I'm an engineer in Android, and I'm working on ABFS right now. So we'll talk about the background of ABFS. We've already heard in some of the previous talks some of the pain points of doing Android platform development, and then talk about the details of how does ABFS help you with your sync and your build, and then the architecture of how we're rolling it out right now. And that tied into the deployment strategy. So what is ABFS? It is a tool to use file system magic in order to make our Android platform syncs and builds faster. So we've heard about the Android sync time. Depending on your network situation, it can take you between 20 minutes and 2 hours. Show of hands, who has a sync time? So like fresh machine, no Android code. You try to download the whole Android branch. Who has more than an hour? Who has more than 2 hours? More than 3 hours? 4 hours? OK, still some hands up. So we've heard from some partners, at Google, we're like, it's not that bad. We have 128 core machines, and all the networks are connected. It's not that bad. But some of our partners, they're experiencing maybe a whole day, a working day of sync times. And that's because Android has over 1 million files, hundreds of gigabytes of source. And then we move on to build, and with 128 cores, it isn't that bad. But we can see partners, again, experiencing multiple hours of build times. And that's because we're generating so many artifacts and more hundreds of gigabytes of files. And then we talk about once you have this synced build and you just make a small change, you want to rebuild. And ideally, an incremental build works for this situation. And at Google, we have teams that focus on keeping the incremental builds reliable. But we've heard from a lot of partners that the incremental builds at their companies aren't reliable because developers have dependencies that aren't declared that they might accidentally depend on, or they've declared a dependency that they don't actually need, which then slows down your incremental build time. And then there are more miscellaneous problems, like a build step that's not the same every time you execute it, so it's not hermetic. And then if you're trying to work on Android, maybe 14, 15, 16, you're quickly going to run out of disk space if you have completely separate checkouts, or if you need different branches for various reasons. So a few solutions that exist today and have been existed in the past. We have RBE, which is a great solution provided by Google, and it is generic but applied to Android. And it allows remote execution, so your local machines don't have to execute everything. You can have this build pool in the cloud, and it can execute things for you. But it only has about 70% cache coverage, and because of that, usually only provides a 30% speed up in our environments. And then local mirrors, they can take an additional 500 gigabytes of space, but then it allows you to have multiple clients pointed to that mirror that could set up in as little as 6 minutes. But then you have the problem of needing to update your mirror and then updating your client, and et cetera. So, and it still has the first time sync the same amount of time, so that's a problem. And then we have some solutions with disk replication, either using like a VM solution and moving disks around, or a shared network file system. But that relies on incremental builds being reliable that we've talked about before isn't always the case. And then there are some file systems that virtualize Git, like ABFS does, but often these are kind of testing and not production ready, and many of them are read-only. They don't work on a write basis. So how can writing a custom file system help with build? The main thing is that we can provide hints and observability that a regular file system doesn't. So each file in the file system, we can provide the checksum of it very quickly. So it's all a content address file system. And we can provide lazy loading. So that allows us with ABFS, you've heard before, to sync the whole Android platform in seconds. And the main feature that enables this is the lazy loading. So with lazy loading, a lot of people ask, don't we pay the cost later anyways? Because you're just delaying the sync until the build, and then you're going to have to download all the files. But that's not actually true in Android for a lot of cases, because there are many files that you don't use during a build. For example, if you're just building one part of the platform, or even if you're building the whole platform, you might not use the test files. You might not use entire parts of the tree. And then also, if you have multiple checkouts, like we talked about, multiple Android versions or multiple different branches on your machine, there could be 90% of the files are the same. And so those won't take up separate disk space and separate load times on your local machine. And then with ABFS, the build functionality that we'll talk about in the next slide, if you have a cache hit on the build where you've seen something built before, then you don't even have to download the content because you can just reapply the output of that build and you never had to download the source files. So we see an example here in this terminal up here. We make a new directory, and then we run this ABFS mount command. And somewhere in those logs, it shows that we mounted in under a second. And then we can go into that directory and ls, and it looks like a normal Android tree. So your machine thinks you have a full Android checkout in a second. And then we can go into a directory like art and ls again and see the whole directory. And so the contents of it aren't downloaded until we're running ls. And then we can run git show, for example, and see that we can see the commit. So we also virtualize the git directory. So it's not an actual git checkout, but our content addressed file system is git compatible. So we kind of fake the .git directory so that most of the git commands work. And you can use this as your read-write developer file system. So now moving on from sync, we can talk about the build part of it. So if we look at the example on the top right, this is what would happen the first time when nothing has been cached before. So in this example, we're running GCC on a hello.c file. And we check this against the cache. We have the checksum of the hello.c file from our file system. And we check against the cache. Has the cache seen this file before with this build command, with the environment variables, kind of everything you need to capture? This is everything that you're seeing for this build step. And in this case, it's no. So ABFS actually executes the command like it would on a normal file system. But before we execute it, we start monitoring. So we can see what are all of the files that this build step, GCC, reads and writes. And you can see in the green box that it reads a hello.c and hello.h file and writes a hello.o file. So for example, if the developer forgot to declare hello.h as a dependency, that would be a hidden dependency case. But now since ABFS is the file system, we can track that that file was read. And that allows us to have correct incremental builds. So next time, if the hello.h file changes and the developer had that as a hidden dependency, a regular file system might not know, or the regular build system might not know to rebuild that output. But because we are tracking all of the hidden dependencies, we do know that we need to rebuild something if a hidden dependency changes. So all of that information gets stored in the cache. And then if we look at the second example, we see this time it's the same build command, gcc hello.c. And with the same checksum on hello.c, we check against the cache, and we see, OK, this has been seen before. And then instead of actually executing GCC, we basically just pull the written files, hello.o, from the cache, and we can create them in the file system. And again, hello.o is lazy loaded, so we don't actually even download that content. We just set a checksum. So then you can see how this all stacks on each other. Then later, if hello.o is used by another build step, then that content, and it's a cache hit, then that content would never get downloaded. And so if you have 100% cache hit, for example, you wouldn't download any of the output. It would just all be faked on the file system. And then when you go to actually use your image file or whatever you're looking for from your build output, that's when something would actually get downloaded. So you might only download one file from an entire build. And to enable this, I don't know if you're familiar that Android uses Ninja as its main build execution right now. And Ninja is similar to Make in that it uses timestamps. So what Ninja normally does is it would see, did the hello.c file, is its timestamp newer than the output? And then if it is, then it rebuilds. If it's not, then it doesn't rebuild the output. So we have basically re-implemented Ninja that is checksum based, and we call it Ninjago, because it's written in Go, so it's Ninja Go. Yes, that is how the build works. So now we talked about some of this. So because ABFS is generic at the file system level, we don't need special features to enable different build, because the Android has GCC, Rust, Kotlin, Java, has all these different compilers. And we're just a file system, so we don't care what command you're executing. This enables us to have 100% cache hit rate. And we can build everything from scratch in under 2 minutes if it's been built before by either another developer or by CI. And like we talked about, you can have reliable incremental builds because we're tracking all of the hidden dependencies. And also, we can detect any unusual file access patterns. So we've had a few cases internally where, for example, a developer was creating hard links when they meant to be creating soft links. And this also, one of the features that we're working on right now, coming up soon, is enabling remote builds, because you can see, since everything is content addressed and we have the checksums of everything, it doesn't really matter where it's executing now. If there's a cache miss, it could execute on a remote machine or a local machine, and then you can just apply the output to the cache. So here, on this example terminal, we'll show we've already mounted a directory, and we've run source build/inv setup. And you can see we do the launch command, which executes in like 10 seconds, like normal. Sorry, I went back. And then you can see we're doing mdroid dist, just like normal. And this build completed in 1 minute and 21 seconds, because everything had been built before. So this is basically just the time it takes to fly through these 200,000 build steps and apply all of the entries from the cache onto the local file system. And then if you, as a developer, are going and changing something, then depending on where you change it in the chain, there might be 10 or 30 or so build steps that need to re-execute, and then it would be a reliable incremental build. So one of the tools, since we're tracking all of these real dependencies, hidden dependencies, this allows us to do something that maybe we didn't intend in the beginning, is dependency analysis, because we have this in-depth knowledge of the whole Android build graph. And so you can see this is one of the applications, is a web UI that we built, where each of these rectangles is a build step that was executed as part of this build. And this part isn't shown here, but like if you click on a build step, it'll show arrows to the other build steps that created the output that the new build step depends on that you selected. And you can see on this tab, well, not really the text of it probably because it's small, but you can see that we format the build command so that you can see what is the build command that we're executing. And then on this tab, we have the writes tab. And the little line in red shows that there was one extra write. So in this case, the build step wrote one extra file than what was declared. And that might not seem like a problem, but there have been cases in the Android platform where one step will write a file that wasn't declared, and then later another build step will depend on that file that wasn't declared. So then if those execute out of order, because the build executor doesn't know that they depend on each other, then that's where you can have broken full builds and incremental builds. And then in this read section, you can see most of these reads were expected, but there's one little line in red where there was a hidden dependency also, and we can report on those. So the UI is just one way of reporting on this, but we have some command line tools also that can generate these reports and can be given to our our main Android build team that they've used to fix Google incremental builds and keep them working. And so the UI is just one way to show that, but this allows you to analyze it, in your Android platform and see what your developers are doing either on accident. So right now, ABFS is available to partners in an early access program on Google Cloud. And we have some partners trying this out right now. And so I'll walk through the architecture of what that setup looks like. Starting from the right, we have Garrett servers here. And we use Git to access the Garrett servers. So if it's not Garrett, if it's Bitbucket or something else, then we just use a Git interface to access them. And so we have these machines shown to the left of that called upload daemons, and they're basically repeatedly polling Garrett and uploading all of your new source code changes to our main ABFS server. And the reason we do this is so you don't have to access Garrett at runtime. And so ABFS server right in the center has all of the data. And right now, it's showing a persistent disk, which is where all of the data, the content address data is stored, but we'll talk in a couple of slides on how that's changing soon. And then you can see around the ABFS server, we have cloud monitoring, cloud logging, and snapshots for reliability and the standard Google Cloud features around that. And then on the left side, we have, on the upper box, we have the developers. And so you heard a little bit about cloud workstations already. And so cloud workstations we're working on integrating that with ABFS too, so that you can quickly have these cheap, lightweight clients that you can spin up. They can be pointing to any branch. You can get these builds in under 2 minutes. And but then also your developers can use their local workstations and have all these same features if they already have the machines that they're used to, and they might as well use them. And then we have CI/CD also, so they can all be pointing to the same ABFS server and reading and writing to the cache. And then we're also working on features if you only want CI/CD, for example, to write to the cache and want the developers only to read from the cache. So right now, the deployment of ABFS is automated with Terraform. We have this open source project that you just define a few variables about where is your source code and various things like that. And then when the machines spin up on Compute Engine, they can download the Docker images if you have been entered into the early access program. And then they can be downloaded and run. And everything just is set up for you. So we talked about how the ABFS server is currently using persistent disks, but we recently just rolled out a change internally to enable Cloud Spanner, which allows us to be more scalable, obviously, in terms of throughput and the amount of data, and it also uses Google Cloud Storage for the large blobs. And we're not limited to the throughput and size of a single persistent disk. And this is going to roll out to the early access partners soon. And for ABFS, we have these 3 phases that we're talking about. So right now we're in early access where a select few partners are testing this out. And then we'll move into self-managed where we have a commercial offering, basically the same technical setup that we talked about now, but it'll be available to a wider audience, anyone who's interested. And then the third phase is that we would offer a managed service so that partners don't need to be as involved into how many Compute Engine machines are running this part of the service and what size are they. So it would be all managed for you. And yeah, thank you. So we have this Google form that is used to register access to our early access program, but you can also use it if you're interested in learning more and talking to your Google Cloud representatives. And thank you for listening.
Thanks for staying. It's us again, Florian and Mike here. We want to talk a bit about the Horizon deep dive in this 20-minute session to go into a bit more detail into elements. As always, everything's shared under NDA and subject to change. You know us already, and what you've seen before, we've introduced Horizon as an open platform, and now you've heard more about cloud workstations as a way to develop more efficiently, bring up dev environments much faster, and also you've heard about ABFS. So ultimately, you can see that the aim of Horizon is to bring these things together and allow you to quickly spin up these things, as we've seen in the recent hackathon. But obviously, we're also here to support you in getting things up and running. But this is essentially our aim here. So we've seen a couple of components here, but as you've already seen that, I'll be quite quick to just skip that. What I want to focus on, perhaps with more detail, are to allow for flexibility. What are our core principles with Horizon also moving forward? It's essentially, the aim is to have a reference platform. So on one hand, it should work out of the box. There are certain pre-configured steps and pipelines and tools that you can use from the get-go, but you can also adapt and change things in a way that fits with your enterprise requirements, etc. We also acknowledge that you essentially need to change certain things, hence why it's open and you can look into all the aspects. Secondly, our focus is on automotive. There are perhaps usually or similar types of use cases and developer flows where also other industries would benefit from this. But here we really focus and have started to look primarily at automotive here. So you can expect more automotive first focus on Horizon moving forward. We also intend to augment existing platforms instead of replacing them, allowing you to really use this as a next component within your tool chains, because we see that there are multiple environments and there are different spheres or levels of testing. So you can expand that. Horizon for Android-specific tests and combine this with what you have already in place. You've heard from Taid also that many things are done as code. Within Horizon, everything will be provided as code that allows you to easily deploy this. So less of clicking around, more like configuring a Terraform vars file, for example, and pretty much deploying things, and you can get up and running. So it really makes it easy to get started, but also it makes it very easy to create dev environments, sandboxes that you can easily spin up within a few minutes and tear them down whenever you need to. It also allows you to have a reproducible behavior, which is quite essential if you want to bring up environments up at a later point in time, and you also need to have a traceability. Open source first, I've already touched upon that. It's important for us to select open source tools wherever possible and also use best-in-class proprietary tools only where no open source is available. Here we, for example, leverage MTK Connect. And last but not least, we really want this to be a modular architecture. Therefore, we focus on separation of concerns, meaning that we want to separate platform, tool, and the workload layer. And you've seen that previously also in the pipeline setup, that there is a base infrastructure that you deploy with Horizon that essentially spins up a Kubernetes cluster and related pieces. Then on top of that, you deploy tools. So you can already see that you can add your own tools next to what's already available. And then you run specific workloads there where we, for example, provide pipelines for the CTS testing, but again, fully extensible to what you want to focus on.
Then let's have a look together at the architecture itself. So this is just a very high-level overview of what gets deployed once you would basically do a Terraform apply with the different code that we provide in the open source repository. So on the one side, for example, looking to the right side of the picture, we have different devices available, like Cuttlefish virtual device or also AVD. And in addition, you see in the middle, for example, a lot of basic infrastructure on the one side being deployed, as well as tools, applications, and also the workloads on top. All of this you can then customize and tailor to your actual needs. And also, for example, on the left side, what you see as well is application lifecycle management. You also see, for example, a Garrett logo. In this case, it would be an open source Garrett that is just deployed together with the platform, and you can decide then at a later point in time if you want to replace it, for example, with the marketplace offering that we've been working on together with Garrett Forge. In addition, you also see some logos like, for example, Helm, Jenkins, and so on. In this case, we selected Jenkins as the overall orchestration layer. However, we separated and built most of the scripts that they can easily be transferred to other CI tooling. And especially in the area of CI tooling, we already have it on our roadmap to provide additional tooling support. Because I would say some companies are using Jenkins, but there are also other companies that would rather not like to use Jenkins. So depending on the overall setup, I think there's a lot of preferences there, and there we want to keep it flexible and also support additional orchestration tools going forward. Looking into way more detail on the platform, I think this might be tough to read, at least for some. Sorry for that, first of all. But you see that there is, on the one side, some parts here highlighted in green that are already available in the release. And there are more boxes in gray that are not yet available. So there's a lot of content that we're still planning for upcoming releases. And just to mention some of the workloads, so for example, if you look somewhere in the middle box, top left, there are the different pipelines that we have, pipeline templates. For example, there you would find the Android Automotive OS build workload. So the workloads that would then be triggered whenever you execute a build. What you will also find in there is tools like, for example, securing access. You will also find this MTK Connect tool for remote device connectivity under applications and tools. And also we have some logging integrations, caching, artifact storage, and so on. So what you see is it takes quite a lot of different components and tools in order to build Android Automotive OS efficiently. And our goal was to put it together in form of a reference platform that is easily deployable and that we can then also maintain over time and basically provide additional tools going forward and support also then latest Android versions whenever there are new releases. So that not every individual needs to do all of this work on their own.
Let's have a closer look at the build part in the coming minutes. The fact is that there are many CI systems out there, and we've chosen Jenkins for now, as it's been used here and there. But as said already, if you want to make this work with GitHub, GitLab, Bitbucket, Azure DevOps, etc., there are ways to do this. You can see in the screenshot here as a proof point that these pipelines that are now currently working with Jenkins are quite easily portable to other CI systems. So much of the logic from Jenkins has been taken out and being sort of kept in script files that you can then repurpose with other CI tools. That's the benefit here. So dedicated logic is being stored there. You can leverage it here, and you can make it work with a CI tool of your choice. As already mentioned as well, we plan to support other CI systems in the future. And if you want to do this now, we're also here to help you and discuss how this works together with these specific pipeline scripts. One critical aspect that's highly relevant with automotive builds is the need to retain artifacts that you generate and keep repeating your builds and have a footprint, have a versioning of environments you have up and running for doing maintenance changes, security patches, etc., and also perhaps to stick to some of the regulatory requirements for retaining these environments or code for a number of years, and can be many, of course. What's important to state here is that with Horizon, you have pipeline jobs that essentially create container images. And these container images within the flow are stored in GCS, so our Google Cloud Storage, and they can be or should be frozen and tagged with the respective release. So this means you can store them there. Within Cloud Storage, we have additional features like auto class, and you have also different storage types to make also the storage cost efficient if we talk about lots of images that you want to store there. And one benefit as well is that our cloud storage, in essence, is really easy to use and has the same API across classes, whether you have standard storage or even archive. So it also makes it very easy and also cost efficient to retrieve certain artifacts from the past. That's essentially important here, because if you want to rerun this, you can tag this to your release. You can also pretty much, because of infrastructure as code, you can also have a certain version footprint of the full pipeline and infrastructure that you intend to use. And therefore, you have repeatability, and you can retain these artifacts for quite some time. Here we've already talked upon it, so I'll just recap that it's very important to note that because we hear that, moving certain built environments and infrastructure into the cloud also has a different aspect. I have my service running in the cloud. I see the cost directly, of course, and it can also obviously has a cost aspect of running this. But it's very important to highlight that you can fully configure the speed and the size of machines that you want to use here. So, for example, for the build farm, and the leveraging of Kubernetes and the auto-scaling mechanism of instances getting spun up for your tests or builds and then getting spun down. You can configure the machine sizes as you see fit. You can do some empirical testing, as we would recommend, to really see for a usual build, it takes, for example, X number of minutes. I want to get this down. I can increase the machine size, and I can really correlate and compare, okay, this is the added cost that I have of having a larger machine instance for this, but if it's worth for me, and typically it's it is, I can increase the machine size and therefore have even faster builds there. On top of that, we do further things like the warm workspaces that allow for even more optimized build times. And to wrap up also the ABFS session, once integrated with ABFS, you can even have even faster and more reliable incremental builds. So it really is a phased approach that you can start off with Horizon in a sandbox, quickly going into dev environments, sort of flicking on the switch for ABFS, and there you go. A couple of points on flexibility, because we obviously acknowledge that this is key. Here are a couple of capabilities that are worth mentioning. There is a customizable Android manifest if you use that and want to bind that to your builds. You have a customizable build machine type, as mentioned, where you can really go from powerful machines to something that is perhaps slower and has a better cost-benefit ratio. You can select even different disk type. So we go with balanced SSDs for now, but you can also go to standard SSDs that further improve the performance as they have higher IOPS. You can have a local AOSP mirror, so to avoid frequent networking traffic to go to the AOSP. You can have a local mirror there to further optimize things. And last but not least, you can also do patching and forking of repos with Gerrit, either the self-hosted Gerrit that comes with the Horizon deployment from GitHub, or by using the Git Gerrit managed service.
Good. Then let's have one look into testing in more detail. And there, the overall testing approach is split into two parts. The one part is basically the test execution pipeline. The other part is the instance template. And the instance template standardizes the setup for testing, whereas the execution pipelines then makes use of these instances for running the tests. This is in more details the different jobs and also parts involved in the testing setup. So we have there a pipeline job that does the different steps in order to fulfill and execute the tests. And there, first of all, the different machines are launched, and also the virtual devices are launched on these machines and waited until ready state. Then we are using this MTK Connect in order to access these devices, and MTK Connect both supports remote access of physical devices as well as virtual devices. So you could execute tests with such a pipeline either on virtual, or you could also combine it with physical devices, whatever is basically required for your setup. Then CTS execution will be done. Then afterwards, devices are stopped, and the test results are archived. And with these test results, you can then look into the results, check them, and download them or basically have them for later usage. The tests themselves, they're executed on virtual machines on Google Cloud. In this case, we typically use normal x86 machines that support nested virtualization. With that, we could either execute multiple of these virtual devices on a single large machine, or we could also have basically isolated machines when we choose smaller machines and have it executed that way. When looking into testing in general, then on the one side, there is the possibility to integrate it to any CI/CD system setup. So meaning whenever you use Horizon, this is just a module that you can use for testing and that you can also integrate with other parts depending on what you already have. With using MTK Connect, you can also connect it quickly to hardware test farms and execute tests on physical as well, triggered in cloud and orchestrated in cloud. And there's also the possibility for some mixed mode testing whenever you want to combine some virtual and physical test benches. This whole setup can also be used for other types of test execution, for example, VTS, Catbox, and also other tests. And in this case, it's anchored to a subset of CTS. And it is basically possible to use the setup as kind of smoke tests. So meaning with every change that you would submit to CI, you could execute a subset of the tests and then give early signals to the developers to see if they broke anything or if the build was successfully tested. And this prevents, I would say, late findings of severe errors. So we've seen set partners or setups where, for example, CTS was only executed maybe quarterly or every few weeks. Internally at Google, we execute a subset of CTS for every commit. And with that, we can guarantee that we can easily fix CTS issues and that we can also easily trace it back and prevent them from even being barred of the repository in first place. And especially if you only execute it every few weeks or months, then it's typically very hard to guess which actual change was leading to a failure of CTS itself.
Lastly, I'll just spare a few words on the remote device connectivity. Essentially, it's allowing you to have shared devices with engineers regardless of their location. Most importantly, there is secure and standard connectivity. So trust me, especially if we're now looking into a cloud-based environment, then you have ADB, SSH, maybe remote desktop connectivity, etc. These are all different protocols and ports that need to be opened, and your network admins are not often that happy to do that. So MTK Connect provides a nice way to provide a simple HTTPS WebSockets-based solution that makes things way easier. And it provides also out-of-the-box connection options and custom interface drivers to make things work. But what's better than showing a couple of screenshots? It's actually going next door and visit the Accenture colleagues where this demo is actually being shown. So you can see these boarding screenshots in real life. So just a couple of things, up to 4 devices that you can add. You can also, besides devices, you can view terminal ADB logcat output alongside, which can make things quite nice to work with, and also include remote desktops, RDP. What I like actually is to have the option to have a live camera there with perspective correction and clickable access. That means that I can have my direct screen share, for example, of my Pixel tablet as shown in the demo, but I can also have my camera stream. And if there are, for example, error messages or certain notifications that I would not see, for example, after some restart, I can actually see them via the camera. So I have like a complementary stream there to make things work if I'd have a physical device connection there. But yeah, check out that demo and hear more about that if you're interested. Perhaps a couple of words on the roadmap. Yeah.
Then we will just have a look on, I would say, roadmap on very, very high level. So we only added the, I would say, absolutely top components that we will focus on. So there will be a lot of additional components that we plan to integrate into each release, but these are the main ones. So in Q2 this year, we initially launched the first open source release of the Horizon platform. So it's available on GitHub and can directly be used. For Q3, what we are focusing on is the ABFS integration. So you've seen ABFS in detail, that it's currently under early access program. And we also want to make it part of the reference platform. So meaning that we can deploy an ABFS setup also directly with deploying Horizon. We would have just some config parameters in there, which would say deploy ABFS, basically yes or no, or true or false, and then it would either deploy or not deploy. And the same we intend to do with Cloud Workstation. So there you've seen a separate repository. What we want to do is integrate it into the existing Horizon repository and also make it part of the overall setup, connect it already, and also equip it with ABFS itself. And this is the focus that we are looking into for this year, and there will be more features upcoming. And if there are specific features that would be relevant for your use case, then just feel free to reach out to us. We also accept contributions as it's an open source project. So in case you want to add something on your own, also feel free to either directly submit a pull request or approach us, and then we're happy to discuss if this is something we're already working on or if we can maybe get it prioritized for you. Then thanks a lot for attending the session, and we would then open up for Q&A.
Oh, hi, everyone. Sorry. Now we're going to open up the QA sessions for the group up here at the podium. So if you have any questions, please come up here to queue up and ask away. I'm sure there's a lot of interest around this. Any questions? We have questions online, too, so we can go there if you guys are a little bit shy. No questions? Oh, okay, go ahead, sorry. No, go for it.
I know I'm asking this right at Google. Any support for Azure? I know I heard GitHub mentioned Azure or AWS.
For orchestration, so for orchestration tooling, there we are quite flexible. So meaning if you have, for example, an existing setup with Azure DevOps or with GitHub Actions or with any other orchestration tooling, this is something that can be easily integrated. For the overall platform, we don't intend to support Azure or AWS. So as it's open source, you might be able to port parts of it. However, for technologies like ABFS, you see that we rely on specific Google Cloud technology like Cloud Spanner. So it would not be possible from our side to bring these technologies to other hyperscalers.
Awesome, thank you.
Okay, we'll go to a question online. There's been several.
The online question, is the full CTS executed on Google Cloud, and how much time does it take to finish the test?
So the CTS executor is on Google Cloud. So we have a setup that the executor is on a specific machine and then interacts with the virtual devices. And it depends a bit on which subset you execute for CTS. So we had one customer case where we were looking at an on-prem setup of CTS execution, which was taking approximately 1 day. And we were reducing the test setup with sharding and so on, I think, to something like 1.5 hours. I think it depends a lot on which instances you choose and also on the overall setup. And we're happy to share more in detail results or also look together into that.
Maybe one more question from online. SDV is mostly developed in Rust. Does ASFP Android Studio for platform support Rust development with syntax highlight like Rust Analyzer?
Yeah, ABFS team is not, we are talking about Android Studio for platform, right, or ABFS?
ASFP, Android Studio for platform.
Okay, Android Studio for platform, they do have a plan to add that as a part of the roadmap, and the team will share the more on the Rust support. But right now, the Rust, a lot of people using the Google OS to use it, and with Cloud Workstation, you can set it up.
Okay. Maybe one more question. Are there plans to open source ABFS?
Yeah,
right?
You can answer. Not right now. There's no plans to open source ABFS. The plan is the broadening the adoption through the Google Cloud self-managed solution, and then eventually a managed service.
Thanks, Eric. Any questions from the audience? I see one walking back. Oh, yes. Hi.
So for AWS, it looks there is a roadmap to support a local host. Is a local host a pure enterprise internal network, or still depends on the Google Cloud?
This is for ABFS?
Yeah, it's ABFS.
So you're talking about if a local developer workstation.
Yeah.
Oh, self-hosting.
Yeah.
The server components will need to run on Google Cloud.
Oh.
But then your developer workstations could be local machines or could be anywhere as long as there's a network connection to the server on Google Cloud.
Okay, thank you. Clear.
And maybe adding to it, so there the private Google Cloud network will be used, and you can peer it or connect it with your local on-prem network. So this is a setup where you have then a secured network where you can both have the clients and the server side in the same network.
Marius Petri, for the Horizon team, a question. The MTK Connect, I found no information on the gas or Android Automotive part. Is very similar to the Firebase Cloud Lab technology, or is something proprietary, or how can we use it?
So MTK Connect is proprietary technology. It supports both Android Automotive OS. However, there's also, I would say, other systems and operating systems supported as well. You will find references in the Horizon repository to MTK Connect. And there the image is referenced, and it's also then deployed out of the box. For further details around it, or if you're lacking any information around it, we're happy to follow up and look into if we were missing to publish some of the details.
Okay, thank you.
Thank you, Florian. We'll have one more question, and then we'll go to a break. I'll turn it over.
Thank you. I think last question for the session. This is on the Horizon build. At this time, it's only supporting Android build, right? Any plans to extend it to non-Android builds as well?
Yes, so we have plans to also support builds from other systems. So one specific thing that we're currently working on is classic AutoSAR. So basically with the OpenBSW implementation. This is something that we want to support going forward. In addition, we also believe that adding things like Yocto Linux and additional systems will be beneficial to have them integrated in one system, and to then also support testing setups where you can test not only an infotainment device, but also combined testing setups.
What about the Qualcomm's HQX build? Any plans to bring that as well?
We are in discussions in general with Qualcomm, and we would need to check in detail with Qualcomm.
Okay, thank you.
Okay, thanks everyone. We'll take a break. Please come back at 3:05 p.m. and you'll hear my voice in the hallway again. So please come back at 3:05 p.m. Thanks.
sensuel. everybody, how's it going? Hope Bootcamp is going well so far. Today, I'm going to be telling you about how you can use generative AI to transform your in-vehicle experience and your experience around the vehicle, leveraging tools that we have in Google Cloud. So if you're interested in building your own agentic experiences or bringing AI assistance to your drivers, this is a great opportunity to do that. My name is Calvin Barnes. I'm a product manager in Google Cloud, working specifically on the product I'm going to talk to you about today, Automotive AI Agent, but also agentic AI in other areas of automotive. A reminder, this is all confidential and under NDA. We are going to be talking about some deep dive components today, how we build this, how you can build it, our architecture. So we just ask that you please don't share that. So as AI is advancing, as I'm sure all of you are seeing at Bootcamp here today, but also on your own apps and phones, whether that's with Gemini or our other experiences and competitors, the expectations of drivers and users of your vehicle are also shifting. They have an expectation that the same experience that they have with other applications is going to be what they expect when they get in the car. And as these experiences become more intelligent, more personalized, more tailored to their needs, and more responsive to those needs, we see that users are going to have basically the same expectations of all the pieces of technology they interact with. At the same time, we think that as these improve, there's big opportunities for brands that can take advantage of them and customizing them to expand their overall ecosystem and relationships that they have with their customers and users. So ultimately, we think this will create a lot of new opportunities for auto OEMs and those in the space. It can help establish the vehicle as just one other surface that drivers and consumers can depend on to get them the information they need when they need it, and serve as an extension of the rest of their digital life. From the OEM perspective, this is a good opportunity because this creates an option to have a stickier experience with your drivers and your customers, right? If they know they can expect certain things in the vehicle, they can also carry that over to their next car purchase or what they choose even when they rent a car maybe. And finally, you can use these relationships and the information that you build to create new opportunities for business, whether that's related to service or in-vehicle subscriptions or even expansion to elsewhere in the ecosystem. And the idea here is that all of these experiences can be owned, managed, controlled, and branded to whatever your specific OEM is, whatever, or maybe it's multiple brands for some of you. And we think that this is an interesting time because as we shift the type of experiences that users are capable of, we will be able to really uniquely address the needs of those users in the vehicle. And I'll talk about some of these use cases in a few minutes. But it's also an opportunity with generative AI and this shift to what we view as next generation assistant experiences for brands to really take it to the next level themselves, right? What will enable these experiences to be great is having deep integration with the same things that they are powering. So if you can have an assistant that knows everything about what's happening in the vehicle, everything that's on the screen, every error code that has been said to the user, then you can provide a much more thoughtful response than just talking to the assistant that's on your phone. If the assistant's capable of controlling every single thing in the vehicle because it's a truly software-defined vehicle, then the use case for when you can use your voice to control something as opposed to trying to change it on the screen or with a dial is even more compelling. So I'm going to give some examples now. We have our fake auto OEM symbol. And let's see how, with some of these experiences and some of what we're talking about, we can start to shift the driver experience and their expectations towards new use cases. So it starts, I think, with the infotainment screen and the assistant basics. So this is everything that users expect from voice assistants today, but completely branded and integrated with the rest of the vehicle UI. So controlling the climate or maybe windows in the vehicle, controlling the media system, whether that's streaming apps or the radio, working with the Bluetooth connected phone for calling, messaging, and talking to your contacts. And then also just chit chat. Maybe you want to ask it to tell you a story or ask it about the weather or latest news. So I think with next generation assistants, and even with the current generation assistants, probably most of you that are working in this space are aware, many of these things are already possible today. Where we think that generative AI and owning the experience can help you take it to the next level is, like I said, this deep integration with the vehicle. So let's take a little bit more complex use case now, where a customer is asking about what this light is on their dashboard. Maybe it's a check engine or error light. In this case, we can use the information that's available from the car as well as the manual to provide a real answer back to the user that this is exactly what this light means and here are the next steps. I'm going to talk about this one in depth later when we do the architecture overview and life of a query, so I won't go too deep into it right now. But the opposite is true as well. So the same as being able to get more information while you're in your vehicle, you can also leverage this new agentic experience to get more information and more control over your vehicle, even when you're not in the vehicle. So you could plan your day or your route or see what's coming up next in your phone. In this case, we're showing in this symbol app. And then seamlessly transfer that context over to the vehicle when you get in it. Another big opportunity is with multimodal models. I'm sure some of you have seen the Scene View or other exciting demos here at Bootcamp, but imagine this integrated with an assistant in the vehicle, where you can use images or videos as additional context with the query from the user, so that you can say things, like, can I park here, or how much does it cost to park here, and do additional processing. OK, so now I'll get into what's hopefully the more exciting part for most of you, which is how we're enabling this and how it actually all works instead of just what the use cases are. So all of this and building the AI-defined vehicle, we think is an important part. And so in Google Cloud, we are building a product specifically to help auto OEMs build and realize this future. And that's called Automotive AI Agent. Ultimately, Automotive AI Agent has 3 different components that you can use and that I'll talk about as we go through the architecture and the rest of the talk. It starts with what we call the pre-built agents. This is all the use cases that I was showing you before, which is basically out-of-the-box functionality. The assistant already does everything that you would expect it to in the car, working with the Bluetooth-connected phone, controlling vehicle subsystems, working with the navigation and mapping application, working with media systems, so that it's already smart enough to do the basics. It just has to be integrated in to get the actual context from the vehicle. In order to do that, we make a series of tools available that we call the design time system and platform that allow you to customize these systems and integrate them into the vehicle, but also expand them. So if you have your own use cases, your own specific systems that you want to integrate with or your own experiences that you want to create for your drivers, you can use these tools available from Google Cloud to do that. And finally, the platform provides an integration layer so that you can have one consistent experience across all of the different surfaces that your users interact with. And so the idea of Automotive AI Agent is, yes, you can use it to power a in-vehicle assistant experience where you can have the user interacting while they're in the vehicle, just like they're used to with the assistant experience today. But you can seamlessly hand that over when the user gets out of the vehicle to an application. And you can also use that same backend in other areas. So if you have other services like your call center or dealership or other places that you want to leverage the same information or the same agentic system, you can integrate it there as well. This allows for not just one shared experience, but also experiences across surfaces. So maybe you can start an interaction in the vehicle, but finish it on the phone. Or take an action that can only happen from your phone directly while you're sitting in your vehicle. So here's basically how we make all of that work. So it starts with SDKs that run both in the vehicle and on the phone that allow you to collect information and send it bidirectionally back and forth with the server. For the in-vehicle SDK, we also have a complete on-device stack so that when the vehicle isn't connected to the internet, you can still interact with it, albeit with some limited information or some limited capabilities, I mean, so that you can still do things like controlling the HVAC system or the radio, et cetera, if they don't require going online. But this system also handles sharing information back to the server and to the cloud when the device does come online. All of this happens in an SDK, so that final presentation layer of what the assistant looks like, sounds like, what the wake word is, all of that is completely customizable as part of leveraging the SDK. On the mobile app side, you have another SDK that basically allows you to access the same systems and data integrated with your existing mobile application that you already have and that users already expect on their phone. On the back end in Google Cloud, this is the pieces that we're building to enable all of this. We have our Gemini foundation model, which is the large language model from Google that enables everything, as well as all of the pre-built agents that I mentioned before, and any custom agents that you have that you might want to speak to. And then all of this is integrated with the third-party systems necessary to make it happen. So you can create integrations with your own APIs that are providing data coming directly from you about the vehicle. So that could be user information or vehicle information or owner's manual, and also integrations into third parties so that you can have deep personalization with things like Google Calendar or Spotify. That the user can take and use. And then ultimately, this is all served up through what we call the AAA server orchestration layer. And this is where you define the actual agent interactions. What's the personality of the agent that users are interacting with? What types of options does it give users in the vehicle or on the phone, depending on the different experiences that you want to create. This could also vary by vehicle or by brand or by trim level, all with your own customization of how it's treated in different scenarios. OK, so now we're going to give a little bit more insight into how this works so that if you are interested in building your own agentic systems, you can get an idea of what's necessary and how you can build your own agents, integrate them with the vehicle, and create your own experiences. In the case of out-of-the-box things that are part of the pre-built, you wouldn't necessarily have to build all this on your own. But in this case, we're going to go back to the use case that I was talking about earlier, which is the user has a maintenance problem in the vehicle. They have a light on. In this case, it's an error with the braking, but maybe that isn't indicated in just the error light that comes up on the dashboard. And so we're going to show how you can go all the way through from starting with the user querying their in-vehicle assistant with, hey, Symbol, what does this light on my dashboard even mean? So as soon as that happens, everything starts with ASR and with speech. So you have a custom wake word engine that understands hey, Symbol, and is going to start actual recognition of what the user is saying. In the AAA SDK, the ASR system is hybrid. So it starts transcribing locally. So even if there was no connection to the internet, they would still see what they're saying. You would still be able to transcribe this. But it also will start streaming all of the audio to the server side in the event that this query is going to be fulfilled on the server. After the user's completed their utterance, so they've said, what's this light on my dashboard? We can do orchestration. So again, staying on the device side for a case to enable fully offline scenarios when necessary. We see, what do we need to do to resolve this? Probably we can figure out from this context that the user is asking something about the manual. This is something we're going to need to use a larger manual, and probably we'll need to use some third-party or online resources in order to be able to answer for the user. So everything gets deferred to the server side, and we make a determination that ultimately this query should use device context plus a tool that knows about the owner's manual, plus some instructions that we also have to give back to users when they want something from the owner's manual. This allows us to package up all of the information that we need from the device to send it to the large language model so that it has the complete context for answering the question. So probably for this, with the light on the dashboard, this includes some CAN bus signals or other error codes that are coming from the device, which are all then sent to one model. So this model knows that it should use the owner's manual. And in this case, we have our fake car FAQ agent that's designed specifically for answering questions about the car. And it can look up this error maybe by text, maybe by error code. Maybe it can include both in the owner's manual, but also other resources. So maybe as the OEM, you can have your own proprietary database of error codes that can be looked up and additional information that can be provided. So the agent would decide, OK, this is about a problem with the car. I'm going to see if this other database has any information. You could also use the actual owner's manual of the vehicle itself, where you can search through and see if there's any information about that light or code, whatever it is, in the owner's manual. The model will then use all of that information that it's found from the context in the owner's manual, plus whatever external OEM-specific tools we have to try to prepare a response back to the user. Once that response has been synthesized, so I think you saw it before, it's something like, oh, this is about the regenerative braking system. Try doing this when you stop the car, or something like that. We create the final agent response. We send it to TTS so that we can actually speak back to the user. And then we stream those audio bytes back to the vehicle. All of this is happening through the single socket connection between the SDK and the Google Cloud AAA API, so that you don't have to worry about calling multiple systems, and you can keep latency low. And then, of course, yes, we play this back with audio focus through back to the user. Maybe you include some other information, like you have some animations or something like that, or you could display some text to the user, but you play back what this means. And so now I've gone through in maybe too excruciating detail everything that happens to answer that one query that the user has made in the vehicle. But let's think about now what we can do later, right? Because our goal here is not just building the assistant, but building a complete agentic system around the vehicle. So let's think about a situation. Maybe I got this answer in my vehicle about the brakes. I took the suggestion to look at it, but I didn't really remember what the agent said to me when I asked in the car earlier. And I was driving. I obviously can't check my brakes while I'm on the highway. So now that I'm home, I remember something that happened, but I'm out of the car. So I open my Symbol app, and I see, OK, what was going on with that error that I got before. So this starts in the companion SDK in the mobile app that I mentioned before. And it can call into the agent system and see what's going on. What is this new request that we have? So it can share that back. And then, assuming the user wants to, you can now kick off another agentic flow. So you could imagine this more like a chat or voice flow in the application, where the user's saying, what does that error that I saw before mean? Maybe they're looking at the history. Maybe they have another question, right? And so with this, we can either have audio or text playback, where I can see the same conversation that I had before with the car, and maybe even ask additional questions, right? I can say, what does this problem mean? Or, how can I solve it? Maybe do additional research or have a conversation with the agent about what might be necessary. Let's say ultimately I decide that to fix this problem, I need to book a service appointment. Now, right from the same agent, using a service booking tool, I can take that action as well. So I'm still in the app, and I decide, OK, let's book a service appointment. And now we can kick off a custom agent for service appointment booking. So this would work, again, by calling into that same Gemini agentic system, using a custom agent that's been built to go back and forth about potential booking options, maybe refining the location of the dealership that I want to go to, or the exact time that works for me, providing additional information, et cetera. We're again here calling out to an external data provider, maybe calling the API to actually book the service appointment, et cetera. And then finally, all this is surfaced back to the user in their app, and they now have a service appointment ready for them whenever they booked it. And so you can see that's how we take one interaction or one service light that happened in the car and turn that into now a complete OEM-owned experience of helping the user or troubleshoot what's going on, try some things on their own, explore it in the app. So now they're on another surface and another touch point with you, all the way through to booking service at a dealer. And the goal is to basically make all of this possible with as little work from you and as little customization as possible. So all of this is based on Google's Gemini foundation models. This is how we enable all agentic systems in Google Cloud and at Google. And then we've built several components within the automotive AI agent ecosystem, starting with the tools that I talked about, the various SDKs that you saw, and the cloud backend, and our pre-built agent that are available as building blocks. But then you have custom agents that you build and a presentation layer and UX that's completely owned by the OEM. So from the customer's perspective, they're not interacting with Automotive AI agent or with Google Cloud. They're interacting with your brand. And we think that this will make it much faster for you to bring generative AI and these types of technology to market with you and with your customers, while still retaining access to all of the data that's generated from these scenarios, from queries about turning up the volume all the way through to a complex query like booking a service appointment, I just said, and fully integrated with the vehicle. So the look and feel of the UI is the same as every other aspect of your vehicle and application. But still allowing you to take advantage of the pre-built components and pre-integrated solutions that I was talking about before. And I think that I am at time. So hopefully this gives you a little bit of insight into how you can build your own agentic experiences for vehicles when you're interested. And I'll be around in Q&A and after if you have other questions. Thanks very much.
Hey everyone, welcome to Google Partner Bootcamp. I'm going to be talking about all the new fun stuff that's coming for Google Maps in the near future. Hi, I'm Raj. I'm with the Forward Deployed Engineering team. We're a partner-facing team that helps teams integrate Google Maps features in their vehicles, all the way from UI to everything in between and all the way to ADAS data and everything. You've seen this 100 times already, but it's still valid. Everything shared is under NDA and subject to change. Here's the agenda. We're going to go over density-independent pixels primer. I know we've all seen this before, but please bear with me. It'll be a foundation for the rest of the deck. What's launched pretty recently, widescreen maps experiences, improvements to limited maps. What's coming in the near term this year, which is map UI customization, and things that are in development for the future, like future concepts. Density-independent pixels. As we all know, AAOS is not a phone, where the distance between the screen and the user is relatively the same across every phone that's out there. In vehicles, we're dealing with, this is a traditional form factor, a cluster and a landscape display, but as OEMs trying to differentiate each other, we're cramming more and more screens in, and distances from the user, occlusions from the steering wheel, regulatory requirements that cap font sizes and everything. There's so many things in play. Enter density-independent pixels. This is mostly a DP equals one physical pixel on a screen in a 160 DPI. That's a formula, but like how does it equate? As you can see, there's a crappy low-resolution screen and a high-resolution screen. And both the text in both the screens are the same height. What does this do? How does this help? Well, it mostly doesn't help OEMs, but if you look at it from a Google Maps developer perspective, we need to scale across how many of our partners we work with, all the hundreds of screens and platforms we work with. And as you can see, we're on the right-hand side of this table here. When we set 240 dp, we expect it to be, let's say, 10 millimeters across on a screen. It will be 10 millimeters on any screen type that you deploy, right? If we operate in a pixel space, we can never scale. With the amount of partners we're onboarding, and anything that you launch today, and anything we will launch in the future needs to be scaled, and we only operate in DP. And why am I bringing all of this up? We've seen some issues in the past where misreporting DPI numbers. If your screen is 160 DPI, 200 DPI, 300 DPI, please report them correctly. Selecting the correct Android pixel density buckets that lets us set the correct DP on our end, which reflects on the screens when the users see them. And this is not just a Google Maps issue. It will be the same for developers that are developing apps in Play Store for your vehicles, because they rely on the same logic as well to scale. Here's some helpful resources on how to set the correct DPI, DP in the settings. So AAOS documentation listed there will explain everything that I just told you, maybe better, about density-independent pixels. You please use the display calculator that's available that takes into account the distances from the screen and the user in arcmins and DPI and suggests a good pixel density bucket you can choose. Also, the map safe area calculator. Plug in your details, and it'll give you the correct safe area you need for your cluster or any of the maps experiences you're embedding in your vehicle. You've done everything correct, and it's still off by a few millimeters. Please use this as a last resort. This is a display scaling function that's available in MVI today. As you can see at the top, that's the one-to-one scaling, and the bottom is 30% boosted. You can see some of the, everything gets kind of stretched out, right? I'm not using the term stretched out pretty loosely, but as you can see, it's a little zoomed in. This is a little drastic, but again, this should be your fine-tuning knob to fix map scaling issues, and once you've set everything correctly. With that out of the way, and it'll start making more and more sense for the rest of the slides on why I'm bringing up DPs. We're going to look at what's launched today. These are available today in your vehicles if you're integrated. We've recently launched the new widescreen cluster maps. As you can see, in the earlier versions, everything was stacked in the center, the turn card, the polyline, and the chevron. We've now separated them out in widescreen clusters. So if your cluster has a safe area that's marked in purple box here, larger than 720 dp, this will be available for your users today. As you can see, the turn cards moved to the right. The ETA panel has also moved to the right, which opens up the space for chevron and the polyline to be more visible. Also launched are the widescreen search experiences. So if you have a maps display safe area set at 1350 dp, you will get this. So users no longer have to scroll to get the same information they can naturally get in the second screen you see, like the chargers and what's available, what's the speed, what's nearby, etc. We've also been working hard on the limited maps activity as well. That's the one before and after. As you can see, there's a quick actions menu, like charger, restaurants, coffee, etc., and home and work quick action menu at the bottom. We'll also start sending cues to folks if they've not signed out to sign in as well, or motivate them to set work, like this screenshot here, to better utilize the Google services. Moving on to map UI customization. So this is more of a pilot that we're running right now with most of our OEMs. And this is like more high-touch, one-on-one engagement we're looking to do. And this is a, so this is a much requested feature from all of the OEMs that we work with. How do we harmonize the Google Maps experience in your vehicle so that it doesn't stick out, but it blends in with the vehicle experience? But before we dive into what's going to be available, here's what's available today. You can either choose a standard map style or a ambient style. Standard is going to be standard, whatever is available in all the Google Maps mobile app that you're aware of and use every day. Ambient is going to be a little more muted. This just blends in with your vehicle UI. So this is the near-term feature that I was talking about. What's customizable? There are 5 things that are customizable that we're planning for: accent colors, UI text, card backgrounds, turn card, and corner radii of the cards. This is just the first list we've prepared. We may add more things in the future, but this is where we're starting with. How does this look once you've customized? So this will give you a quick snapshot of what it might look like when you customized it. As you can see, the turn cards are changed, colors changed, etc. Notably, the base map is absent here. That's by design. We put in lots of R's, working with users, user testing, to figure out what works best for the users. And we feel like base map customization goes a little further where the users don't feel natural. And there's also contrasting requirements, other stuff that we want to show, highlight, like, for example, polyline and everything to the user. And at the end of the day, this is a Google Maps, Google first-party product. And we want the users to readily know that when they look at a maps, they know that it's a Google Maps product. So that's why we're holding off on the base map, and we're going to let OEMs work with us on the UI part. So how does this customization going to work? Please get in touch with your FDE, PBD, or your partner engineering folks show them the slide, they will put you in touch with the correct people. But essentially, you give us your color UI palettes, we'll generate a mock, we'll give it back to you, and we'll iterate on it. Once that's done, we'll provide you a style ID. With that style ID, just place it in your config in your vehicle MVI, and we'll make sure we serve the correct map style when the vehicle comes online. We've seen near term. I'm gonna present what we're looking for in the future. It's things that are in development. We're still gathering feedback on some of these pieces. Customize your widescreen cluster. We're looking to customize some of the turn card, as you see. Right now, it was separated, could be unified, or could be a big block where we can add more information there. Also, we're looking at chevron placement as well. That can be customizable. And non-rectangular screens. Clusters can vary wildly, even between the same platform in your vehicle line. So how do we manage that? How do we set a safe area for the map part, safe area for the turn card, other information, just so we don't block it? Or like, let's say, a vehicle prompt needs to be shown on top of the map. How do we show that efficiently? So we're still thinking through that ideas, but we're definitely thinking at non-rectangular screens. Place card is another thing that we're looking to improve in the future. So this is the current place card, as you see. It's pretty minimal, but there's a lot of information that's available in your mobile experiences. This was by design. When we started, we had to be cognizant of driver distraction and not showing too much information that they can't consume. So we're looking to bring rich context into place cards pretty soon. Pictures from your Google Maps, user reviews. AI summaries, where we give a short blurb about the place that's easily digestible, even when you're driving. Big data insights, like parking information, is it busier than usual, things like that. These are available today in your Google Maps mobile app. We're slowly bringing them into automotive experiences as well. And this brings me to my final shiny, fancy slide. This is the vision or UI we're looking to do in the future. As you can see, we're not considering traditional form factors. We're considering other pillar-to-pillar form factors as well. But the devil is in the details. When you get to implement this, we don't know if the top screens are controlled by QNX or third party, or if it's an Android display. If we need to bring this rich, seamless, amazing experience for users, we need to collaborate with OEMs much earlier. If you think, let's say you're developing a new screen and you think, oh, Map should be involved, you're probably too late. Please get in touch with us. Any of our partner engineering folks or partner engineering folks you're assigned to, we'll be happy to work with you. I personally believe that there's no better app than Maps in a vehicle, and I think it should be celebrated even more inside a vehicle with more rich context and information. With that, thank you.
Hello, everyone. Next, I will talk about the enhancement we made in the vehicle engine model, and including VM Lite, OEM dashboard, and battery preconditioning, and a few more things enhancement we made in the past few years, 1 year. My name is Zishi, and together with my colleague Lavang, we from the forward deployed engineer team from the Geo department. As a reminder, everything in this presentation is under NDA and subject to change. First, agenda. So we have 4 sections. I will talk about the VM Lite and the OEM dashboard, and then Lavang will introduce the battery preconditioning support in vehicle engine model and talk about the new things and upcoming things in Vega engine model. Let's start from the Vega VAM Lite. It is a kind of a lightweighted Vega engine model that allowing our OEM to provide the minimal parameters in the model, but still can produce decent engine forecast as a good starting point of the Vega engine model tuning. So maybe let me start with a little bit of recap of how the Vega engine model works. So Vega engine model, essentially, it combines the world data, including the real traffic speed, real-time traffic speed, and the geometry from the Google Maps, and the information, the Vega engine model from the OEM. And the Google Maps combines those two information together to produce engine forecast and the EV user experience to the users. And the VAM Lite works in the same way. But the difference is, with VAM Lite, OEM will be able to provide less parameters in the Vega engine model. It will serve as a good starting point of the tuning and testing. Essentially, it will allow our OEMs to get a car on the road with the working Vega engine model with the full EV functionalities of Google Maps with minimal parameters, only 7 parameters. Why it is impressive? Because in the full VAM, it requires essentially hundreds of parameters to get a working Vega engine model. Now we only need 7 as a starting point. And you may have a question about how it works, why we only need such few parameters. That is because the VAM Lite, it is still backed by the full Vega engine model. And internally, on Google side, we will generate the full VAM parameters based on the VAM Lite. And we will use the generated parameters to calculate the engine forecast in the same way as we do in the full VAM. And how to work with the VAM Lite. So it's quite straightforward. So OEM can always start with the VAM Lite with the minimal parameters, 7 parameters. Then we can start tuning and testing. And in the tuning loop, the OEM might need to add the full VAM parameters back to the model if the quality of the VAM lightweighted parameters doesn't meet the quality bar. And the OEM will need to repeat this process, testing and adding full VAM parameters back until the model has a decent quality and performance that meet the certification criteria. That's the VAM Lite. Then let me talk about the OEM dashboard. It's a little bit different. And it is a web tool that is accessible by our OEMs. You can use this to monitoring the performance of the Vega engine model for the vehicles that is already launched in production. So this chart describes high level how it works. So basically, Google Maps running in your vehicle will collect the data, including the energy consumption and the energy prediction onto the cloud. And on the cloud, and we have the algorithm, we are to aggregate the data. And during this process, we will handle the privacy and the security and the legal properly. Finally, the data will be available in the partner visible dashboard. We call it OEM dashboard. Then you can see your data from your vehicle. And here's how it looks. Basically, we will show the data in a unit of watt-hour per kilometer. And there will be 3 curves in the chart. The first, the blue one will be the forecast error. That is the watt-hour per kilometer error differences between the actual energy consumption and the prediction. Then we also provided the energy forecast, not forecast, it is the actual energy usage in the same unit, watt-hour per kilometer. And the third curve is the sample count, basically the yellow one. It will give you an idea how many samples we derived this data from. Basically, more samples we have, more reliable the data will be. In this mock example, you can see the curves and what we can tell from this chart. It shows the error changes. You can look at the blue line. The error change at a different temperature, and we can tell as the temperature goes warmer, and we are seeing the error is going higher. And in this case, as OEM, you can go back to your vehicle engine model to look at the temperature-aware parameters at the higher temperature. And potentially you can find the issue and fix the issue and deploy the fixed issue via OTA update. Then OEM partner can continue to use this dashboard to monitor the performance and the improvement you made. And besides the error by temperature, this dashboard will also provide the data by the altitude and the error by the vehicle speed. How to enable this dashboard? So to enable this dashboard, we need a sufficient volume of the vehicle running on the road, because our aggregation algorithm requires sufficient data to produce meaningful results. The granularity of the data will be per vehicle model. That means the current threshold of the volume is 2,000 weekly active users. That means once the weekly active users of a certain vehicle model is above 2,000, and we can enable the dashboard for you upon the request. Of course, the OEM can only see the data from your own vehicle. Yeah, that's for the dashboard. And with that, I will hand over to Lavang to talk about the rest of the remaining of the slides.
Hi, everybody. Battery preconditioning. The real-world battery charging curves or charging times may depend on temperature of battery. Nowadays, the most common type of batteries in vehicles, those are lithium-ion batteries that have optimal operation temperature ranges. Typically, it goes in between 15 degrees Celsius to 35. And any deviation from this temperature range can impact negatively the charging times, charging speed of the batteries, as well as the battery life, long-term life. In this particular example, in the graph, you see two charging curves for the same battery, same charging power, but two different temperatures, 5 degrees Celsius and 40 degrees Celsius. Here you see that the charging time for 40 degrees Celsius is faster. Therefore, the charging optimal experience, charging curve will be faster when the battery is warm. The battery's ideal temperature also depends on charging power at the charging station. It means that optimal charging experience will be different. Optimal charging curves will be different when depending on charging powers at charging stations. Energy calculations, the accurate energy calculations by Google Maps consider the energy spent for battery preconditioning. So in this example, you see an EV route to a destination with two intermediate stops, trip 1 and trip 2, for charging. The blue curve indicates the energy consumption during the drive to charging stations. Battery level goes down. And the red curves indicates the rise of battery level upon charge. Normally what happens, vehicles, they start preconditioning battery, cooling or heating just before arriving at charging station. So car manufacturers can use the information provided by Google Maps about charging stations' rated power to determine the optimal ideal battery temperature for preconditioning. At the same time, Google Maps has to know enough information about the vehicle in order to calculate energy consumption total, as well as its component for preconditioning. That's very important for demonstrating or displaying user with the accurate energy consumption values, specifically upon arrival either at the charging station or at the destination about the battery levels. Currently, Google Maps is supporting only heating battery preconditioning. The detailed modeling description can be found in our help centers. And what essentially car manufacturer has to do is provide information about vehicle's battery temperature or energy requirements for changing battery temperature from A to B, as well as, for example, target battery temperatures for different charging powers. Google Maps will calculate energy consumption for battery preconditioning
also including instances of partial preconditioning. That's the case where time for reaching charger is shorter than the time needed for full preconditioning. In this kind of cases, energy estimates will be adjusted by Google Maps for total battery energy consumption as well as for charging estimates. The support for cooling thermal preconditioning is currently work in progress. Next, new and upcoming vehicle energy model features. Kinetic modeling is a feature that allows OEM to enable or disable kinetic modeling of the acceleration or deceleration on the route segments, adjacent route segments with predicted different travel speeds. This feature allows car manufacturers to fine-tune vehicle energy model energy consumption granularity. The other feature is charging power limitations per charging architecture. OEMs can provide information about maximum charging powers per architecture, and Google Maps will use this information for proper or adjusted charging time suggestions to the user. For example, if you have a vehicle with two different maximum charging power limits for 400-volt DC charger and 800-volt DC charger, and depending on where user is traveling to charge, Maps will consider these limitations for charging time recommendations. And finally, last feature is so-called real battery level to display battery level. That's about the current process of battery level assessment has some level of uncertainties. And normally, the displayed values of battery levels in the cars, those are adjusted or smoothed out values. They contain or encapsulate all those uncertainties. With this feature, car manufacturers can provide Maps with the real or raw measurements of battery levels and a function of converting those values to display values. And the benefit of this is that algorithm running for EV route planner can consider these nitty-gritty details for better energy consumption calculations. So the outcome of that will be higher granularity or accuracy of energy consumption for EV route planner. That's it. Thank you very much.
Hello, everyone. So next, we will change the topic a little bit. We will talk about the automotive SDK. If you had a chance to stop by the demo room nearby, you may notice that there are a lot of Pixel tablets there running AAOS. So in this slide, we will talk about how to use the Pixel tablet as a development platform for automotive SDK for Android. My name is Zishi, and coming from the forward deployed engineering team from the Geo department. And as a reminder, everything shared in this presentation is under NDA and subject to change. And first, let's do a recap of the automotive SDK for Android, what it is. So it is a kind of a headless version of Google Maps for Android Automotive, and it also provides ADAS data. And it provides partners with the core components needed to build a first-class navigation application. It including routing, guidance, search, and texture. And this diagrams is showing the high-level architecture of what the automotive SDK is composed. But today, we are not going to dive deep into how it is, the architecture, but talk about how to start work with Automotive SDK. Basically, here is a brief instruction. The full version can be found from our help center. So basically, there are three steps. First, you need to download SDK. There are two parts, the API and a service package. Then, to integrate the Automotive SDK into your Android image, two things need to be done, the configuration, and you need to add the service package into the Android image. Then, you will be able to use the API from the gRPC call. So ultimately, it will look like this diagram. With the SDK API and the service package installed and configured, OEM can use the API to build their own navigation applications. Quick start with the Pixel tablet. So Automotive SDK for Android is designed to work with AAOS seamlessly. And we can use the emulator, but alternatively, we can also use a device. And here is introduced how to use the Pixel tablet as the development platform to work with Automotive SDK. And the benefits are not limited to, it is portable, and it has good performance, and it is publicly accessible. You can buy it from Google Store. And you can feel it in the demo room if you want. And one caveat, yes, we support the build target for AAOS for the tablet, but on Google side, we have a limited support for the source level. In this slide, I also put a quick launch command here, shows how to quickly set up the build environment, and also a link with the full instruction, which is available in our help center. At last, I put a caution here, because when you play with the Pixel tablet, there always a risk to break the device. If that happens, you can always rely on the Google support to restore the device. And in this picture, it shows the dog food application, internet application built upon the Automotive SDK. And the screenshot is taken from a real device. And what it is and it's not for. After all, it is a tablet. It is not perfect. So we can use the Pixel tablet for evaluation and prototyping. And it is supportable, you can use in the car, but it is not suitable to do deep vehicle integration. And it is not representative about the performance and the stability compared to the vehicle device. And if you know about the Pixel device, you may know, be aware of there's a shortcoming of this device. That is, there's no built-in GPS module in this device. Yes, we can use a simulator, but there will always be scenarios we want to test with the real GPS signal. And there's multiple ways to do that. On our end, we are currently building a tool that can enable the AAOS tablet, the Pixel tablet, to use the third-party GPS signal from a Bluetooth dongle and make it possible to test with the real GPS, even in the car. And this picture shows how it looks. And with the tablet reading the data wirelessly from the Bluetooth GPS dongle, and it can still use the Tesla to access the internet from a phone, and also charging with the USB port from the vehicle. And furthermore, we are also exploring options to collaborate with our partners to implement a facility to utilize the real data from the vehicle bus. Here is briefly described how the GPS solution works. And basically, it will be a standalone Android application that reads the data from the Bluetooth dongle and plumbing the data into the location stack of AAOS. Also, it's not just for Automotive SDK. So you can use this platform as a developer platform for all the other Geo products, including Google Maps, VMS SDK. And finally, at last, as a wrap up, this table listed all the things we need to use it as a development platform, including hardware, operating system, and required software. Yeah, that's it. Thanks.
Okay. Hi, everyone. Welcome to the final session of today. Our presenter today is covering the Android Automotive Bug Report tool, which also called AABRT. Sorry? Oh, yeah. My name is Joy, and this is my coworker, Kwang-an. We are software engineers working on developing Android Automotive Bug Report tool. Before moving into the main topic, just a quick reminder that all the information covered today is confidential under NDA and is subject to change. So here's today's agenda. First, we'll introduce our AABRT and then explore how the Bug Report tool works. And then we'll introduce our new app, V2, with its some key changes. And then we'll finally walk through the partner integration process. So let's start with the introduction part first. Before introducing our tool, let me first explain the conventional method for creating bug reports in Android. For a long time, Android has been providing a bug report through ADB commands for debugging issues. However, this requires laptop, ADB, and a US connection, which makes it difficult to quickly generate bug reports in a real-world environment. So recognizing these limitations, we developed a dedicated bug reporting application so that users can create bug reports easily without these prerequisites. Okay, so now you may understand why we are providing a dedicated bug reporting application. But why was it necessary to develop a new Android Automotive specific application? Why didn't we just simply adapt the existing solution from mobile? The answer lies in the fundamental differences between in-vehicle environment and mobile user environment. So let me elaborate on the key features of our app that have been specifically optimized for this automotive context. First, we recognized that typing on a screen while driving is difficult. So our tool provides voice recording, which allows users to verbally report bug descriptions. And second, AAOS typically uses headless system user mode. So in our app, bug reports are managed within the user zero to decouple the bug reports from any specific users. Third, AAOS utilizes a multi-display environment, such as instrument cluster display. To help with debugging of US issues, especially on the secondary displays, our tool captures multiple screenshots from all connected displays. Last, our tool offers a powerful workflow integration with Google Tracker to automate a ticket creation. It can also be configured to file a new ticket directly into the partner's designated component. Then let's see how the app has been changed. It first originated in 2019 as an AAOS platform app. This version was built with the platform source, so was tied to the OS release cadence. So in 2024, we transitioned to an unbundled app model. We decoupled our app from the OS, which enables fast development and release. However, this still required our partners to manually update the pre-built application in their system images, and also still restricted to debug builds. To resolve these challenges, we are moving to a new model V2 in 2025. Once V2 is released, V1 will be entering into the maintenance mode. So we are not going to add any new features. We'll just fix critical bugs issues only. But this doesn't mean that V1 will be deprecated. We will keep providing V1, especially for our non-guest partners, because V2 is distributed through Play Store. So V2 has its own release schedule and is closed source. The most important thing is that V2 supports production builds, which finally allows you to leverage this tool across the entire vehicle lifecycle, from initial development to the post-launch support. Okay, then let's deep dive into the technical details. This slide shows the architecture of the AA bug report tool. This is structured across 3 distinct layers: Android platform, Android application, and our backend server. At the bottom layer, we have Android platform. There is Car Bug Report Manager, which is a key API to expose the necessary interfaces to handle the bug reporting process. Alongside it, the VHAR provides the vehicle's current state, such as whether it is driving or parked. This information is used for optimizing the user experience. And in the middle layer, there is an application. As you can see in the diagram, the application works across multiple user spaces. In the current user space, it directly interacts with users to record their voices and collect the bug report. And the collected bug report is then stored through content provider and will be uploaded to Google Cloud Storage through Uploader. And these components are running in user 0 to guarantee bug reports are uploaded safely if when a current user is deleted or changed. This layer also includes RRO, which allows you to apply the specific configurations or customizations. And finally, the top layer is our backend. The AABRT backend retrieves the bug report and then communicates with Google Issue Tracker to automatically create a new ticket with the summarized formative information for easy triaging and debugging. So these 3 layers collaboratively work to provide an end-to-end solution that seamlessly collects data from the vehicle and delivers it directly into the development workflow. From this section, we will introduce our new app, V2, with some key changes. V2 has 5 major changes. Let me briefly explain each of these changes in this slide. First is the transition to Play Store app. This means you no longer have to iterate the integration process for every new version. And this reduces an engineering burden and allows frequent feature updates and quick bug fixes. And the access is controlled securely. Only listed users will be able to download the application from the Play Store. And V2 is using keyless client-server communication. V2 no longer requires the credentials files that was previously used for Google Cloud Storage authentication. This change not only just makes the setup easier, but also enhances security by removing the sensitive files from the build system. And V2 optimizes UX for driving situations and starts supporting screen recording, and also improves the user privacy by providing an in-app consent for data collection. Okay, then from the next slide, Kwang-won will explain each feature more in detail.
Thanks, Joey. Hi, my name is Kwang-won, working with Joey on AABRT. This slide shows the improved user experience in version 2. We have moved from the dialog UI to a persistent notification service. This allows users to start report collections, record their voices, and receive reminders while you are driving. Version 1 required a hardware or software button binding for driving situations, but it's no longer a strict requirement in version 2. Similar to Android Mobile, users must provide consent for each bug report, which is a mandatory requirement of the API design, because this requires additional user interaction while driving.
This consent process will be skipped and deferred until the car is parked. When troubleshooting, video is often more helpful than a static image. To protect user privacy, this background video recording will only begin after receiving explicit user consent. This consent must be provided each time the feature is enabled or when the system restarts. The last n seconds of screen activity will then be automatically recorded and attached to the final bug report. The version 2 provides a new settings page where you can enable or disable features like notification service or screen recording. Importantly, any features that may affect privacy are disabled by default. Okay, now let's discuss what you need to do to integrate AABRT into your systems. Integration for version 2 is much simpler than version 1. It's a one-off task. You will download a zip file that includes a Google-signed stub APK and resource files that I will explain in the following pages. You will then build your system image with the stub APK. This will allow the end user to download the actual application from the Play Store. Here is the specific build file configuration for the stub APK. You will need to import the stub APK in the Android.bp file, ensuring it's marked as privileged and pre-signed. Then add the import them name to your product packages list. AABRT version 2 requires several privileged permissions that must be allowed listed in your system. Here is the XML snippet you will need to add. There are two more configuration steps for the bug report to manage API. First, you must add the app's package name to the bug report dash whitelisted configuration, as only allowed listed apps can use the bug report to manage API. Second, you need to specify the Google permission controller as the approval package to handle the user consent process. Because AABRT version 2 is not a public application, you will need to follow a few steps to get access. First, join a specific Google group for access control, and then use a play link to become a tester. The detailed instructions and links will be provided in the integration guide later. For our non-guest partners, the version 1 unbundled app will still be available. The integration process is more complicated though, as it requires you to build the APK from source code, including credentials and creating an overlay app. For the details, please check out the link in this slide. If you want to see how the version 2 is working, please come to the demo room. We have a demo devices installed with BRT version 2, and you can try using it by yourself. Thank you.
Hi, everyone. We're going to move into the Q&A session for the last couple. So if the teams could kindly come to the front. Any questions that we want to take from the room? Oh, if you have, please come line up behind me. You have a question? Yes. Okay. Let's wait for Kwang-eun and Joy to get up there. Could it go a little faster? A little faster? No, just kidding. I'm just kidding. I'm just kidding. Sorry.
I actually have a question for AAA.
Oh, he's not here. We can't find him. Oh, you can ask. Okay. Anyone else want to come with a question? Okay. Dan?
I had a question about the bug reporting tool. So if Android's virtualized, is there a way to provide system logs from the host, similar to what was done with the dump state HAL with Trout?
Actually, we haven't tested the tool in the virtualized systems. Yeah.
Okay.
Hi, question about the automotive SDK. So is this available for non-gas users, or is it only for as part of the gas package?
I think you may talk with our business team for the contract things, but basically the automotive SDK is not part of gas.
Okay, so you could actually, the contract aside, you could actually.
Technically, it's a different things. You can use auto SDK without gas.
But how would you then do the SDK updates?
That is, I think it's not the topic for today. And sorry, yes.
So Auto SDK is completely separate from gas. Updates will be handled by the OEM.
Okay, so the SDK update. So is there a separate session on it again further coming up? No.
We had a session last year.
Okay.
That's available in the Help Center.
Okay. Okay. No, I just wanted to understand the SDK updates. How it would happen?
In any case, let's say you're doing a companion app and you're integrating a Maps SDK there. How do you update it?
Yeah.
So it's going to be the same framework.
Okay.
Since you assume a lot more of the control of the app, you also assume a lot more control of updating the app.
Okay. Okay. All right. Okay. Thanks.
Thank you, Raj. Any questions from the audience? Oh, Luhai, back again.
So this is about for AI. So is there any plan for Google to support on-device MCP-based AI tooling service?
I don't think the AI presenter is here.
It's for Callum. He's not here right now.
Oh,
okay. We'll save it for him. Any other questions for the group up front? Otherwise, we'll take some from online.
Hello. With respect to bug reporting tool, I saw all reports are going to Google Cloud. How to change that if we want reports in OEM clouds?
Actually, we are thinking about adding the new feature that supports the partner cloud, but currently it's not available. But we can think about it later.
Okay, thank you.
Online question. I think this for the bug report tool, I guess. How can user N access the content provider in user 0? Is this allowed?
Could you say the question again?
Yeah. How can user N access the content provider in user 0? Is this allowed?
I think so, yep.
Okay, we'll take another one.
We are using file handler exposed by user 0. By sharing the file handler, the user N can access the file in the 0.
I think this is for maps. There are a couple of questions, but both along the same lines. Will the customizable maps UI that is shown today be applicable for mobile native maps SDKs, Android and iOS?
Oh, those are completely separate products. Customization workflows for that are completely different. Whatever I presented today is only for gas and gas installations.
Any final questions from the audience? Okay, thanks everyone. Stay in your seats for a little bit. We'll finish the Q&A session and hand it over to Chris for any further announcements. Thank you.